So 2020 was, without exception, a wonderful year for everybody all around the world, myself included. And in 2020, I talked a lot about REST APIs, so much so I even wrote a book about REST APIs. But in 2021, I'm shifting my gaze and I'm looking to the future and I'm looking towards GraphQL. Well, hello, wherever you are, whenever you are, the year is 2021. My name is Les Jackson and the place, at least for me, is Melbourne, Australia. Now I hope wherever you are and whenever you are that you're happy, safe and well. So it's really fantastic to be back here on YouTube. This is my first video for many months. It's definitely my first video of 2021 and I'm really excited to be back. And what a video I have for you, because today, as I said in the introduction, we're going to be building a GraphQL API using .NET 5 and the Hot Chocolate framework. Now, I can really say hand on heart, in all honesty, I love REST APIs, are awesome, but having used GraphQL now, both as a consumer and as somebody writing them for about 6 months, wow, I can really say I've fallen in love with them and I think they are fantastic. And I don't think it's just another faddy technology. I really think they're here to stay. Now, there are some definite challenges with building GraphQL APIs. They're harder to build than REST APIs, no doubt about it. But I feel the payoff for your consumers is awesome. It's really there. And again, I had lots of misconceptions about GraphQL before I used it. So I hope this video not only teaches you about what GraphQL is and why you would use it, but hopefully it will bust those misconceptions if you were like me and you have those misconceptions. Fantastic. So just before we move on to the demo, I'm going to take you through what you're going to be building. If you follow along with this video, just like to say, if you're not subscribed already, please think about subscribing and you'll be notified of any new videos that I make. And if you like the video, maybe give it a like. Again, that just helps me out and I really, really appreciate it. Other than that, we have got a lot to get through. Thanks for joining me, but let's get started. All right, so we're going to begin with a bit of a demo on what we're going to build, but before we do the demo, I think it's worth just talking about the API we're going to build, and I've tried to make this as real world and as useful as possible, okay? And it's the same use case I used in my REST video where I talk about the use of command lines and retrieving command line snippets that are difficult to remember. But unlike the REST tutorial where we just had one resource, which was our commands resource, and it actually had a string for our platform. In this example, and this is really me trying to kind of sell the benefits of GraphQL, I've split out the platform, which is really going to become our parent object or our parent entity, which just is something like .NET or Docker. That's what I mean by a platform. And each one of those platforms can potentially have one or more command line snippets. So it's a much more elegant way of representing those resources. Now, it's not to say you cannot represent resources like that in REST, you absolutely can, and we'll touch on some of the issues with that a bit later. So I'm not going to cover that here. So I'm not saying you can't do this with REST, you can, but it's, I feel, a bit easier and a bit more intuitive doing it with GraphQL. So this is what we have. We have a commands table with our command line snippets and a bit about what they do, and then a foreign key that relates to the platform. So let's just have a quick look at some of the data just to help you contextualize it. So if you do a select everything from platforms, you'll see I've got a few platforms in here. So .NET 5, Docker, Ubuntu, etc. And we have a license key column. Don't worry what that means at the moment. That will become clear a bit later. And then if we have a look at our commands, you'll see all the different commands, and of course they have a foreign key that relates to the ID of the platform, and we can then start working with it in that way. So don't worry too much about the data. It's just kind of rubbishy, simple data, but that is what our API is attempting to do. So let's start querying that API using GraphQL. And again, I'm not going to over-explain it at this point. We do go through it step by step later. So let's just do a .NET run to run that up, and that's going to run on localhost port 5000, as you would probably usually expect, a .NET app. And then what we're going to use to exercise our API is a tool called Insomnia. Now, if you wanted to use Postman, you absolutely can use Postman. And there's actually another tool that comes built in with the Hot Chocolate framework that you can use as well. So we cover all this later. I'm going to use Insomnia. It's just an API request client, and you can actually use it to test REST APIs as well. So let's do a query. Let's pull back all our platforms. Let's do that first. So I've got a folder for my queries. So right click, new request, and we're going to say all platforms. Okay. Now all requests in GraphQL are all post requests. So it's not like with REST where you would have a get request for reading stuff and a post request for writing stuff. Not like that with GraphQL. Everything's a post request, and we'll select GraphQL as the body. And all that is a GraphQL query that we're going to put into the body of the HTTP request. So this is just a HTTP request. No different, no more complex than that. All right, now we're getting a bit of an error here. So what we need to do is put in the endpoint. And this is another difference between GraphQL and REST. There is only ever one endpoint with GraphQL. You don't have to change the resource URI depending on what you're pulling back. So just localhost, port 5000. It's not a semicolon, it's a colon. And then the actual endpoint is going to be called GraphQL. And we'll cover all this a bit later. So let's refresh something called the schema. And this is a really important, I spelled HTTP wrong. This is a really important concept in GraphQL, the idea of a schema. And again, we'll cover that later. But basically, it's what we can do with our API is loaded into this tool now, and it knows the things that we can do with it. So we're going to write a query. And this is just the stuff that goes in the HTTP post body request. And you can see here straight away, it's aware of the objects that we have within our system. So we want to pull back our platform object, and we want to bring back its ID, and we want to bring back its name. Okay, so this tool is quite cool. It gives you kind of IntelliSense functionality. If you just click send, you can see here it brings back JSON. So again, another important point, it just brings back JSON. I mean, it can bring back anything. It could bring back XML if you wanted, but again, it's just a JSON object that's coming back with all our platforms in it. But what you may have seen that's the really cool thing about GraphQL, if you set it up correctly, we can then access the child objects, in this case our commands, and we then just drill into the stuff that we want to pull out from our commands. So for example, how to, and of course the command line snippet as well. Let's rerun that. And you can see here we get back a more verbose output with all our platforms, and you can see we have command line snippets for .NET, we have some for Docker. We don't have any for Windows. We have one for Ubuntu, and we have none for Kubernetes and Red Hat. So you can flip this about, and you can just request the commands. So again, let's do a new request, and let's do all commands. Again, always a post request, GraphQL for the body, create. And I'm just going to put that down here. And I'm going to copy our endpoint. Again, labeling the point, it's the same endpoint for all our requests. Paste that in here. Refresh the schema, specify that it's a query. What query is it? This time we want to just go straight to our command query, and we want to pull out our how to, our command line, and we can then drill in to see what the platform is. And we just want to pull back the platform name. Fantastic. Send that over, and we get just the command line snippets with the child object. Well, it's not the child object, with its parent object, which is the platform. So you can see the power of this, and you can see the fact that you could, if platform had a parent object, or if command line had more children objects, you could drill down as you wanted. You can select what attributes you want to pull back. So let's say we don't want to pull back the how-to attribute to minimize our payload. You can take that out, send it over, and that's gone. And all you're getting is the command line and the platform. So very powerful, I think much more powerful than REST. Now, the last thing we want to do is show you how to create data, so we can create and add a platform to our backend. So right click, new request. So we'll do add platform. Again, always a post request, GraphQL for the body, create. We will copy out our endpoint. So again, the endpoint remains exactly the same. Fantastic, do a schema refresh. This time we specify that it's a mutation. and that's what we call in GraphQL world, and we'll cover this a bit later when we talk about the theory, anything that changes data. And we've got a couple of mutations here, add platform. So we'll specify a platform input, and then we just specify the parameters. In this case, we want to supply a name, and then we'll just give it a name. So let's say, I don't know, OSX or something, doesn't really matter. And then you can see here, it's kind of complaining what it wants us to do. Yes, that's us telling what we want to create the data with, but we then want to specify what we want to display as a return. And the add platform mutation returns a platform object. And then we've got access to all the stuff that we want. So I'm just going to select back ID, click send, and you can see back we get ID 13. If you look in our database and do select everything from platforms, you'll see that that has in fact been created in the back end. So that's a very quick demo. We're going to look at these in a bit more detail. We're not going to cover subscriptions here, which are really, really cool actually, but you will build subscriptions in GraphQL. So that's the demo done. Now we're going to move into the course overview so you can see how we're going to get to this endpoint. Okay, so we're just going to take you through the course overview now, and yeah, just in case you didn't realize, we are doing a GraphQL API using .NET 5, and we're using the Hot Chocolate framework in this case. And yes, this is the first episode of season 4 as well, for those of you who are counting. So this is what we're going to cover. In our introduction section, which is really where we are now, we're going to show you the demo, which we've done already, tick. We're going through the course overview, so we're in that right now. Then I'm going to take you through the application architecture of what you're going to build, and then we'll talk about ingredients and tooling. Next section is a bit about GraphQL theory, and I recommend you watch this section. It's not that long, but if you've not used GraphQL before, then I highly recommend you stay and watch this bit. Now, just on that point, if you do know about GraphQL and you know what it is and all the terms and stuff, then I will put the time codes to these various sections in the video below, so you can just jump straight to the relevant place. And it also means if you're following along and you decide to take a break, you can jump straight back into where you left off. So time codes will be below. The other thing as well, all the code is up on GitHub, and I'll flash down in the video where you can get that code, and I'll also put it in the description below. So the code is there if you want to download it from GitHub rather than typing it in. But I personally like typing it in as I move along. I feel I learn more about it. Anyway, just a couple of points before we move on. So yes, the GraphQL theory, we'll talk about what it is, why you would use it over REST, some core concepts, some core language concepts, and then we'll talk a bit about GraphQL in the .NET world. We'll move into coding then, and again, code is on GitHub, just remember, but we'll do a project setup right from scratch, step by step. We'll set up our models in our DbContext to set up our kind of data layer. We'll then do some simple querying, but then we will need to revisit the DbContext. And I'm not going to ruin the surprise as to why we need to do that, but we will do that. In the second part of our coding, we're going to talk about multi-models. We're going to introduce a second model. We're going to talk about something called Annotation Vs Code First approaches to writing a GraphQL API with Hot Chocolate. Now, so I don't expect you to understand what those mean right now. We're then going to introduce you to types and why you would use them, and then we'll talk about filtering and sorting support as well, especially within the query context. Then coding part 3, we're going to talk about mutations, which I kind of did a bit in the demo, and also subscriptions, which are basically real-time event notifications back to a client. Very, very cool, and we're going to implement that as well. So we'll move on to final thoughts. I've got some ideas for some next steps where you can take this. This is a full API in my view, but there may be some things you could add to it as a next step. So I've got some ideas on that. Do a bit of a wrap up and then support our credits. So that's our course overview. All right, so in this section, we're going to take a closer look at our application architecture. Now we cover this throughout the video, and don't worry if some or all of the concepts in here don't make sense to you. We cover it all step by step. I just wanted to give you an introduction to it to see the kind of thing that you're going to build. So we'll kind of start with our application boundary. We have our program class, which is the entry point for our program. We then have our startup class that's responsible for configuring our services, as well as our request pipeline. And there we are, our request pipeline. I'm showing that on here. Now, a request pipeline deals with requests, but it deals with them in a particular way, a sequential way using middleware. And some of that middleware we need to introduce as part of this request pipeline, most specifically GraphQL. We're adding it to our pipeline, as well as WebSockets, which is used as part of our subscriptions component of our API. We'll have our models as usual. Well, I say as usual, we'll have our models, which we will have in probably most applications. So this is nothing really to do with GraphQL specifically. Anything in blue is not really GraphQL specific. We'll have our data access layer, or DbContext, which I just think of as a mediator between our models and our database. So they take our internal data representations and mediate them down to a persistence layer. We're then going to start with the GraphQL specific stuff, and the first thing we're going to create is a query class, which will allow us to read data, not surprisingly. So we'll work with our GraphQL client to make a HTTP post request, go through our pipeline, hit our query. The query will use our DbContext to pull data back via a HTTP response, which is in JSON, and you've seen that already in the demo. We're then going to introduce this concept of types, which are basically mapped. I like to think of them as just being mapped to our models, and it allows us to abstract away the any GraphQL specific stuff that we may have embedded in our models and extract it out just into our types. And that allows us to not expose our models in their entirety. It means we can hide some fields, for example, that we don't want to expose out via our API. So it's a really important concept. We're then going to introduce mutations, which allow us to create, update, and delete data. And they require two support classes, namely inputs. So not surprisingly, when you're trying to mutate data, create it, destroy it, or update it, you need to provide some kind of input, makes sense. And then you would expect some kind of output, or in this case, a payload as a return. So we're going to introduce those as well. And then finally, we're going to introduce our subscription type, which will allow real-time event notification from our API. So we're building a full GraphQL API, queries, mutations, subscriptions, okay, the full works. And just to round off our architecture section, this is referred to as our schema, but I'm going to go into a bit more detail around this when we cover off our GraphQL theory. But for now, that's our application architecture section done. If you didn't understand all or any of that, don't worry, we explain it as we go, and we will be revisiting it throughout the rest of the video. All right, super quick section, just telling you what ingredients you need. And now again, I will put links to all of the things that you need to download and install attached to this video. And there is a subsequent section later on where we actually go through the environment setup. So, and I kind of take you through this in a bit more detail, but I just want to give you a headline overview of what you're going to need. So you'll need a text editor. I recommend VS Code, it's free. You'll need .NET 5, and again, you actually need .NET 5. It's not good enough to say you're going to use 3.1 or even an older version, because we use some new features as part of .NET 5. And again, I'll take you through that a bit later in a subsequent section about where you can find it and how you can download it. We're going to be using SQL Server. So again, I don't really mind how you have access to a SQL Server. You can have it installed locally on your Windows machine, or you can have it in Docker, which I'm going to do. And again, I'm going to take you through, in our environment setup section, how to set up SQL Server using Docker if you've not done that before. But headline, should I say, is you need SQL Server. I recommend SQL Server Express, or if you've installed Visual Studio, you'll probably have the local DB. It's up to you which you want to use. And again, they're free. And then you'll need a API client, and I'm recommending Insomnia for this video. It's free, or you can use Postman if you're more familiar with that. But for me, Insomnia is actually a nicer interface. It's a bit cleaner, and it has much, much, much better GraphQL support. So strongly recommend Insomnia, but it's entirely up to you. And we're actually going to use a couple of other tools that I'll introduce you to later in the video. And then I've said about 2 hours of your time. I think this video is probably going to be over 3 hours long. So, you know, it's up to you how you want to ingest it. You might want to come back, as I'm sure you probably will do, and revisit it if you want to work your way all the way through it. So probably more than 2 hours of your time, but I'll put that there for now. So that's it. That's our ingredients that you'll need. Everything is free, shouldn't cost you a penny. And I do take you through how to kind of find and set up your environment in a bit more detail later on. All right, so we move on to a bit of theory now, and I think it's worth going through this, especially if you've not done any GraphQL stuff before. So first off, what is GraphQL? So it's basically a query and manipulation language for APIs, as you've seen in a very basic way as part of the demo. But it's also the term we use to describe the runtime that actually fulfills requests. So GraphQL is both the query language, which you've seen when we did those queries and mutations, but it's also the runtime. So the Hot Chocolate framework basically implements a GraphQL runtime that we build around. Okay, so it's both of those things. It was created at Facebook to address some core concepts of over and under fetching, and I'll talk about those in detail a bit later. And it's now open source, so it's now hosted by the Linux Foundation. All right, so let's go through some core concepts. And again, at the end of this, if you don't understand it all, that's okay. I think you'll probably get it more as we move through the coding examples, but I wanted to, in this section here, at least introduce it to you. So you're kind of starting to get a bit of a head start on what some of the concepts are. Now, I've tried to get the core concepts onto one slide, which I thought was quite difficult, but you be the judge and tell me how well I've done at doing that. But the main concept, if you walk away with nothing else from this slide, the main concept I want you to remember is this idea of a schema. And a schema basically, in the GraphQL context, describes our API in full. So the queries that you can perform, the objects it contains, the data types that it has, even down to descriptions or documentation for all of those things as well. And we actually do that in this video too. So yes, it's self-documenting, which is awesome. It's comprised of types, and we'll talk about types in a second. And yes, you must have a root query type. So we talked about queries, we talked about mutations, we talked about subscriptions. As far as Hot Chocolate is concerned, you must have a root query type. So what are types? Well, this is a bit confusing. Types can basically be anything in GraphQL. So a query is a type, mutation is also a type, as is a subscription. We have objects, and I'm sure you're aware of what objects are, but they can contain additional fields and they can contain additional objects, as you've seen, and they can use them to construct more complex business, sort of modeling scenarios. But we then have enumerations, which are basically lists of static values, and we can also have scalar values. And scalar values are just the values that you're probably very familiar with using. Now, they actually call out, interestingly, in GraphQL, they call out an ID as a scalar type. So it's got its own special reference. Integers, strings, booleans, floats, they're all scalar types. And as I mentioned, objects, they allow you to make up more complex things. So in the example of a car, we have a car object, and this language that you see here is the schema definition language of GraphQL. So you have a query language, but you then also have like a schema definition language, and that is what this is here. So here we're defining an object of type car. They will have multiple fields in this case, so make, and make in this instance is a scalar type, which is a string. And the exclamation mark means it cannot be null. So again, yeah, just to elaborate the point, each of these fields will have a given type. All right, so we then move on to this concept of resolvers, and all a resolver is a way in which we understand how to get data for a given field. So I think I've got a comment here. Yeah, so a resolver returns data for a given field. Now, when we kick off our journey into GraphQL, the resolving heavy lifting is pretty much done by the Hot Chocolate framework, so you don't really need to worry too much about it. But about halfway through the video, we change course and we do a bit more of the heavy lifting ourselves, and then we actually start to write our own resolvers. And they can resolve to anything. So your data sources can include other databases, or databases as we're using, another microservice, a REST API, and in fact another GraphQL API. Can resolve to absolutely anything. So very flexible. So these are the core concepts from a non.NET perspective. So yes, that's a really good point. This is a GraphQL core concept. So these concepts are as relevant if you're building a GraphQL API in Ruby on Rails or Node or something. It doesn't matter. This is agnostic from the technology implementation. These are just core GraphQL concepts that you can use no matter what framework you're using. So that's another really important point. And then finally, just in this section, I want to talk about what's wrong with REST. What is wrong with REST? Nothing. And what I don't want you to think I'm doing in this video is jumping on a bandwagon and going, REST is rubbish, never use it, because I don't believe that to be the case at all. However, REST is not perfect. As I said, there's nothing wrong with it, but there are some things it doesn't do so well. So let's take a look at those. So the first idea is overfetching. Now what that means is we return more data than you need. So REST does overfetch. So let's look at an example call to a REST resource called cars. So we're going to bring back our list of cars. And in a typical REST request, you'd get all your cars back. We've got 3 here, and it's going to give you every attribute or every property for your car. Now it may be, for the query that you're making, you're only interested in its ID and the registration number, and the color is irrelevant, but you're still you're still given that as part of a REST request. So you're getting more data than you need. So scaling that out becomes quite inefficient. With GraphQL, as you've seen, you'd specify a query and you specify, yes, we want the cars object, but I only want to select the fields that I want, in this case, ID and registration. So this is passed in the body of a HTTP post request, as you saw in the demo, and you will just get back the data that you want. So it avoids this overfetching scenario. And yeah, we get it back as a JSON payload. So again, one thing I just want to make clear is for both REST and GraphQL, we talk about HTTP posts and what have you. Both REST and GraphQL do not need to be implemented using HTTP. They most usually are, but they don't have to be. They're agnostic from that implementation. And likewise, the payload most usually happens to be JSON. It doesn't have to be JSON though. So just bear that in mind as well. So problem 1, solved by GraphQL, you are getting only the data that you need. So we'll then come on to talking about underfetching. So REST also underfetches, so meaning that you need to make more requests using REST than you would with GraphQL. So you're not getting enough data back. So let's take a look at an example. So we're extending what we did in the last slide, and we're just asking for one resource this time. So we're using the resource ID of 1 to bring back 1 car. And you can see not only does it bring back every field for the car, it's also bringing back our options. Now what are options? Options in this imaginary scenario is a child object of car that allows us to model things like, does the car have, metallic paint and alloy wheels and leather interior, all that kind of stuff. Now, if you're implementing REST correctly, you wouldn't put all that information in the response because, well, you're basically just compounding the original issue that we had of overfetching. So imagine you only wanted a car's ID and a car's registration, and instead you're getting all the car attributes and every option attribute as well. It's not really what you want. So that's not actually solving the issue. Even if you could do that, you shouldn't do it. So what you'll usually get with REST is, yes, you'll get your options array, and it's just a link to the resources in question. And so to get the options information, you're going to have to make 3 additional requests. So it's just this horrible self kind of referential cycle of over and under fetching, and it's not that great actually. And that's why Facebook obviously went, well, there must be a better way of doing this. So again, GraphQL comes to the rescue. So again, just to mirror what we're doing over in REST, we're specifying we just want a car with an ID of 1. We're only specifying the ID and registration attributes for a car, so we're not overfetching redundant information, but we are addressing the underfetching issue by saying we actually want the options included in our payload, but we only want the name and the cost or whatever. It doesn't really matter. Now, an options object could be massive as well. So again, you wouldn't want to, again, laboring the point, you wouldn't want to pull it back here with this request anyway, even if you could. And so what that will result in is a JSON response payload with just the ID of the car and the registration, and then our options array just with the information that we want. So we've made 1 request to 1 endpoint, not 4 requests to 4 endpoints. Okay, so that is the beauty of GraphQL, and I definitely don't think that's a fad. I think that's an absolutely fantastic selling point for any API. So when to use it? So I'm not totally bagging REST, again, I'm trying not to jump on a bandwagon, but I am very impressed with GraphQL. So GraphQL is good for interactive, quote-unquote, real-time type applications, mobile applications, applications that are quite chatty, where you're wanting to pull back maybe complex, there you go, complex object hierarchies just once. Good for that. Good for complex type queries. REST APIs are good for maybe system-to-system interactions, such as microservice, where you've got a more simple object hierarchy potentially, where you're having repeated, simpler queries. The other thing to really bear in mind, and you'll see this as we move through the video, is that GraphQL APIs are much, much harder to create than REST APIs. REST APIs are very simple, but as a consequence, from a consuming perspective, they're not optimal. So the trade-off is, as a developer, REST APIs are easier to write. From a consumer, they're probably not as good as they could be. GraphQL APIs, from a developer perspective, are much harder to write, but from a consuming perspective, for me, they are much, much better. But ultimately, as a developer, you should have a toolbox, okay? You should have a kit bag, or whatever you want to call it, of techniques and design patterns that you can use. So I'm not saying for 1 minute, drop all your REST stuff and use GraphQL API across absolutely everything. Definitely not saying that. And I'm not saying the converse either. What I'm saying is, as a developer, you should have a kit bag and you should understand when to use the right approach, or when to use it. The right approach is not a good terminology. When to use a suitable approach. All right, so the final slide in this section, and I'm going to get off my pedestal or my preaching stand and just talk a little bit about GraphQL in .NET specifically. So if you go to the NuGet package manager website, you will find that it is by far and away the most popular library for GraphQL in the .NET world. It's open source, there's over 4 million downloads. I'm not using that in this video. I'm going to use the Hot Chocolate framework, which is by a group of people called Chili Cream, I think. Again, open source, and it's just under 1 million downloads as of this video. Now, we're using this one, and you might go, why are we using this one? Why aren't we using the more popular one? Well, the Hot Chocolate framework is far newer, okay? It's not been around as long. And based on my own, and this is, flash up a warning, this is my personal preference. I'm not advocating one is better than the other, but for me personally, based on what I have seen and what I have used, I personally prefer Hot Chocolate. It just seems to work quite easy. It seems very robust. I get it. I get how they've structured things. It makes sense. When I looked at GraphQL.NET, I have to say, didn't resonate with me. It might resonate with you, and that's cool. I'm not bagging it, but for me, Hot Chocolate was definitely the way to go. It wasn't even really a choice. It was, I'm definitely going down this path after what I've seen and experienced. It seems to be really well supported. So that's what we're using, and I think it's going to have many, many, many more downloads than that in the near future. So I may be wrong, but we'll find out, I'm sure, in the future. Anyway, that is our theory over, and I think now we're ready to move on to coding up our solution. All right, so in this section, I'm just going to take you through how to check to see that you've got all the necessary prerequisites installed if you're wanting to follow along. So we went through what those prerequisites are in one of the previous sections, but here we're just going to check to see if you have them. So the first thing you want to check to see that you've got is .NET. So at a command prompt, type .NET -- version, and that should return a version number, and we actually need version 5, as some of the new features introduced with version 5, we are actually going to leverage and use in this course. Now, if you get a lower version number returned, like 3.1 or something like that, or you don't get any version number returned and it just doesn't know what you're talking about, you will need to install version 5 of the framework. So over in a browser, you just come over to Google and you just search for .NET. And I'll still use .NET Core. It tends to take me to the right place that I want to get to, which is this page here. So .NET.microsoft.com/download. And you can see here it's detected I'm running on Windows, so it presents me with the options that I have available. And this is what I would want to install and download, or download and install if I didn't have .NET 5. Same for Linux, you'll want .NET 5 SDK, same for Mac. Exactly the same thing. Now I'm not going to take you through how to install it, it's very straightforward. Just follow the instructions on this website. So that's the first thing you'll need to check. The second thing you'll need is a database, and we're using SQL Server in this video. Now there's two ways broadly that you can run SQL Server. If you are running on a Windows machine, like I am, you can install it directly on your machine. And I've actually done that. I have it running, SQL Server Express running in the background. So if you want to do that, just type SQL Server Express into your browser search engine and go to this downloads page. Again, I'll put all the links attached. I'll attach all the links to this particular section. And this is the download you want, SQL Server Express. So if you want to do that, follow the instructions. It's pretty straightforward, and that's you done as far as the database is concerned. If you're running on a Mac, or you're running Linux, or you're running on Windows and you don't want to install SQL Server, then you can use Docker to run SQL Server in a container. That's an option as well. So if you want to take that approach, again over to Google and then just type in Docker download, and you will get various options depending on your operating system. So if you're running Windows or Mac, you can download something called Docker Desktop. If you're running Linux, you just use Docker. Now, if you are running Windows, and specifically if you're running Windows 10 Home Edition, you need to take a slightly different approach to installing Docker, but there is an article here on how to do that. So again, I'll put links attached to this video, and you can install it that way. If you're running Windows 10 Home though, you can just remember install SQL Server directly on your machine if you find that easier. Doesn't matter which approach you take, you just need the database. I'll leave it to you which approach you want to follow. Now, if you are wanting to use Docker, I will take you through in one of the following sections how to actually set up SQL Server in Docker and run that. I'll show you that a bit later. But for now, just want to make sure you've got the prerequisites installed. Cool, so that's .NET, SQL Server. You'll also want a development environment. So I'm recommending Visual Studio Code. So again, VS Code download. And the reason I'm recommending that is because it's a nice cross-platform development environment. It's the same for Linux, Windows and Mac. Looks the same, works the same. So from my perspective, making videos, it's a nice option. It's also a really nice tool as well. So yeah, I highly recommend it. If you want to use Visual Studio, the full-blown IDE, you can do that. You should be able to follow along with relatively few changes required. And if there's anything I can think of specifically that I need to call out that you'll need to do differently, I will of course do that. But generally speaking, you should be okay. If you don't want to use either of those, you can use any text editor that you like and just use a command line along with it. That's all good. So the final thing that you'll need is some kind of API client. I don't know why I minimized my browser there. Let's bring it back up. Now in previous videos when I've been doing REST APIs, I've used Postman, which is a really good option for REST APIs. But for GraphQL, I'm using a different tool, and I'm using something called Insomnia. Now, again, I wouldn't recommend you just search for Insomnia because you'll more than likely get a lot of results about sleep problems, sleep deprivation, so I wouldn't suggest that. So type in Insomnia API, and it will just take you to the download page. Interestingly, it's called Insomnia. It's named insomnia.rest is the URL. We're using GraphQL in this video, obviously, not REST. Now, what you'll need to install is this Insomnia core product, and it is available on Windows, Mac, and Linux. And the reason I'm choosing to use it is it's just got better GraphQL support built in, and I'll highlight some of those features when we come on to using it. So that's it, that's the prerequisites that you'll need. I will put all the links and I'll attach them to this lecture so you can go straight there and download them, otherwise just Google them. Install is very straightforward for pretty much all of these across all platforms, so I think you should be okay in following the instructions provided and installing them. So that's it for this section, and we're ready now to move on to project setup. All right, so in this section, we're just going to scaffold up or set up our application. We're not going to do much coding, we're just kind of going to get it going. So I'm going to open Visual Studio Code by just launching it from my taskbar. I'll bring that over onto my main screen. Now I'm going to open up the integrated command line from within Visual Studio Code, which is one of the reasons I like it. So I'm just going to hold down the Control and open quote or back quote apostrophe. It's the key, well, underneath your escape key and above your tab key if you're using a US type keyboard. I think it's called an acute as well. So it's a kind of single back quote key to open it up. Now at the command prompt, I'm just going to change into my kind of working directory, which in my case is on my D drive, and then it's in season 04 or maybe it's just S4, yes, season 4, S4, cool. And then if I do a quick directory listing, there's a folder here for episode 1, so I'm going to change into that as well. Cool, so let's do a quick clear of the screen. Now, you're probably aware of this, but if you do .NET New, you will get a list of templates that you can select from to scaffold up our application. So the one we want is this one here, the ASP.NET Core Empty project type. So this web kind of key here is effectively the short name, and you use the short name to, well, you'll see how we use it in a second. So clear the screen, .NET New, and then just the short name to select that project type, and then we'll give it a name, and I'm going to call this Commander GQL. And you might see GraphQL from time to time abbreviated as GQL, so Commander GQL. Hit enter, and that will then scaffold up that project. So we'll do a quick directory listing. You can see it here. So I'm going to change into that folder. Actually, no, I'm not. What I'm going to do a little bit of a trick. I'm going to open code up, VS Code up, recursively, which means it's going to open it within itself, and I'm going to give the name of the project GQL. There you go, and it's kind of reopened Visual Studio Code with that folder, and you can actually see the project structure here, which is quite a nice little feature. So yeah, we're going to rebuild our assets. There you go. Now, again, I'm not going to spend too much time going through the anatomy of what you've got here, because we'll kind of cover it as we move through the tutorial. But just very quickly, we've got a project file, and we're going to keep this open in this section, and we're going to add some packages and references, package references to this file for all the dependencies that we need. Our program class is actually our entry point to the application. We're not going to touch that, but this is basically where everything gets kicked off. And then within here, actually, if we take a step back into our program class, basically what it ends up doing is calling our startup class. And within our startup class, we're going to configure two main things: our services, which is done through configure services, no surprises there, and also our request pipeline, which is done in our configure method. But more on that later. Those are the main things that we're going to need. And then actually the other two things that will, well, one thing really that we'll be interested in is either one of these JSON files, which is going to hold our connection string or any other config that we choose to put in. And we can choose either one of these. I'm probably going to put stuff in app settings development JSON as we're working within a development environment. But you can use either one of these really, depending on your needs. And that's probably about it. That's all that's really relevant, I think, for this project. If I've forgotten anything, I will cover it as we move through the rest of the video. So open the command line again. So again, control and back quote or single quote. And I'm going to leave, actually, that's not the right file we want. I'm going to open up this project file, the csproj file, and keep that open. And we're going to just start adding the packages that we need as part of this project. We'll install them using our command line, and they will automatically get added to our csproj file. Now, Visual Studio users, you will have to do this a slightly different way, and you can do it via the GUI or you can do it via the package manager console. But actually, let me show you how you can do that. So all packages come from something called the NuGet package manager. So if we go over to Google, and we just type in NuGet package, that'll take us there, I'm sure. So here we go. And this is basically the package repository where we're going to pull everything from, and it gives you some, well, it actually gives you how you can do it, how you can install these packages depending on what environment you're using. So the first package that we are going to actually work with is the main GraphQL package, which is Hot Chocolate. Hot chocolate, that's right. And actually, if we just type that, that should take us there. So it's Hot Chocolate ASP.NET Core. We want this one here. And you can see here, if you're using Visual Studio, you can install via the package manager. We're going to be installing it via the .NET CLI, or you can just copy in the package reference, however you want to do it. But we're going to do it using the .NET CLI. I'm just going to copy this and then come back over to our command line and paste it in. Now I'm just going to take out this version attribute here. I just want to install, I don't want the preview version, I just want the latest stable release. So .NET add package and then, let me move my cursor out of the way, the name of the package. And the reason we're keeping this window open here is you should see it added up here if it's successfully been added. So you can see quite a few dependencies are being added in here. So hopefully, there we go. After all that, we get this one package reference line, and the latest stable version is 11.0.8. Cool. Next thing we want is another hot chocolate package, but this time it's hot chocolate data.entity framework. Okay, that should be correct. And we'll just do an up key. And again, the reason I like to keep this CS_proj file open is if we've made any typing mistakes, you won't see the entry being added in here. And a few times I have typed something in at the command line, I've not really been paying attention, it's thrown an error, and we've not actually added the package, or I've not actually added the package to the project, and I've ended up chasing my tail a bit. So that's why I like to do it this way. It just kind of validates what you're doing is working and you've done the right thing. So the next one we want actually is an entity framework core package. So do an up key. It's not a hot chocolate package this time. It's a Microsoft package. So Microsoft entity framework core.design. And you can see there's definitely room to make typing mistakes. In fact, I probably should just be copying these over. There we go, but it's installed correctly and it looks all good. And then the next one we want is another Microsoft Entity Framework core package, but this time SQL Server. And this is obviously the package you install if you're using SQL Server. If you're using a different database, you would find the appropriate package for that particular database, but we're using SQL Server. Great. And then there's one last package that we are going to be using in this tutorial, so I'll cover it a bit more in a bit more detail later, but it's basically, it adds a really nice graphical interface to our request pipeline, and it basically allows us to interrogate our GraphQL schema. Now, if none of that made sense to you, don't worry, I'll cover it off in full as we move through the video, but we do need this package. So the package you want is GraphQL.server.ui.voyager. And the tool's called GraphQL Voyager. It's really nice. Yeah, you'll see how that will manifest in later sections, but let's just add it in there for now so we don't have to do it later. So that's really it for our sort of project scaffold and project setup. As I say, we're just adding some packages to make sure we have all the dependencies that we need. So in the next section, and this is an optional section, is we're going to set up our SQL Server in Docker if you're choosing to do that. Now, if you have SQL Server already set up and running, you can skip the next section. You don't need to follow along. Of course, if you're interested in how to do it, take a look, but that's what we're going to be doing next. Okay, so in this section, we're going to set up SQL Server using Docker, and in fact, Docker Compose, if you want to be absolutely correct. Now, you can skip this section, as I've just said, if you already have SQL Server running. If you don't and you want to use this approach, then I'm going to take you through that now. So of course you need to have Docker installed. Now, in fact, let me just start my Docker desktop instance while I'm doing the rest of the config stuff. And you can see down here, certainly on Windows, you get a little, there you go, Docker desktop is starting. So let's leave that happening in the background while we get on with the Docker file. So in your project, in the root of the project, just click anywhere here, new file, and we're going to call it docker-compose.yaml. Okay, so obviously it's a YAML file. Now, YAML, if you've not used it before, is very, very sensitive to indentations and white spacing and stuff like that, so be really careful with how you type in your Docker Compose file. Now, all a Docker Compose file is essentially a set of instructions that we feed into Docker, and it basically tells it how we want it to spin up 1, 2, 3, 4, however many containers that we want. Now, in this instance, we're just spinning up one container, which is going to run SQL Server. Within Docker Compose, we actually refer to those running containers as services. So the Docker Compose file is really concerned with setting up our services. So that's what we're going to do now. So the start of every Docker Compose file is specifying a version, and I'm just going to specify version 3, and then we go on and start specifying our services. So again, colon, and then we want to indent. So again, I've just indented under here, so I'm using two-space tabulation. If you want to use something else, that's of course fine, but make sure you keep it consistent. And if you're going to get any errors, it's going to be in and around either typos or you've not indented properly. So the first thing you do is just specify your service name, and this can be anything. So I'm just going to call it SQL Server, which I think is as good a name as any. And then for the rest of the service specification, I'm going to actually copy that in, and I'm sure you won't hold that against me, just because it's so subject to making typo errors, and there's no IntelliSense or anything, well, not much IntelliSense, so I'm doing it that way. But let me take you through what it is. So again, our service name, SQL Server, and then indent under that. The first thing we specify is the image, and that's basically, well, yeah, what's the blueprint for this container? In this case, it's SQL Server. And these come from Docker Hub in this instance, unless you specify another repository. But in this case, Docker will go to Docker Hub and pull down this image and then run it up with the following configuration. So this section here, we're passing in some environment variables. So the first one is just accepting the licensing agreement. The next one is this system administrator password. And then the last one is basically just the flavor of SQL Server that we want to set up. And we're just specifying, in this case, Express. You can specify the full flavor of SQL Server if you have a license for that, so on and so forth. Again, I'll put links attached to this lecture about the documentation that Docker provides on how to set up SQL Server, but this is basically all you will need. One final thing, you will need to specify a port mapping. By default, when a Docker container starts up, it's not accessible unless you do a port mapping. And basically what that's doing is mapping the internal port within the container to an external port. And it basically means you can then connect into it from your desktop and start using it. So using this configuration here, pretty straightforward. We can then access this SQL Server in the container using this port mapping, just using localhost. Very simple and very straightforward. So let's save that off. Now, one other thing that I do recommend if you're using Visual Studio Code, and this is another reason I really recommend it, is this plugin here, Docker plugin. Highly, highly recommend you install it. Now, if you want to install that, you just come over to your extensions and then just type Docker. And obviously this is the same for any extension you want to install. And it's probably this top one here. Yeah, it's all pretty much got 5 stars. I've already got it installed. Absolutely fantastic plugin. And what that gives you basically is the ability to kind of see what images you have already located on your physical machine. Now, obviously, as I've been using Docker quite a bit, I've got these different images that have been downloaded, and I have, well, this is the test instance of the project I've been running. So let's remove that. Let's get rid of that. So I have no containers configured, and I have no image, well, I have images already downloaded. So in order to spin this up, let's go back to our command line. Let's clear the screen. Let's just make sure, yeah, the file is saved. Do a quick directory listing and make sure you can see the Docker Compose YAML file. And also make sure that Docker is running. And the way that we want to spin this up is just type docker-compose up, and then I'm going to specify this -d, which basically just means the command line gets returned back to me. If you don't specify that, then you basically get loads of status messages and stuff, and the command line's basically then being held by the running Docker containers. I don't want that. I want it to return straight back to me. So if we hit enter, what it'll do is, you can see how quick that was. It's actually spun up a SQL Server already, and you can see up here, we have a running container. Now, the reason it was so quick in my particular case is because I already have this image on my local machine. So when we issued that Docker Compose command, it ran through the file that was specified, it looked to see what image it needed, and it found obviously it needs SQL Server. It then looked in the local image cache to see if we have the latest version. We do. That's why it was so quick. If you don't have those images there, it will go to Docker Hub and pull them down, and it might take longer in your case if you don't have those images there. Nonetheless, you can see how quick that was. It's just spun that up, and you get the little green arrow there to say that it's running. And again, the reason I like this tool, you can obviously stop Docker at the command line, and that's just Docker stop. You can see that it's stopped and it's reflected there, and then of course to run up you can issue the same command, or you can actually right click here and you can stop and restart services as you like. So if you prefer doing it that way, you can do it that way as well, obviously. That's the only Docker type commands you're going to need to run, stopping and starting. Nice and easy. And so the last thing we want to just check is that we can actually connect in to that. So if you're using Windows, I'd highly recommend you install SQL Server Management Studio, which is this graphical tool. If you are running Windows, if you're running Linux or Mac, you will not have access to that. So what you can install instead is another extension for VS Code called SQL Server, and it basically allows you to do pretty much the same thing that you can do with Management Studio. It's just not quite as nice. So in Management Studio, while that's thinking about it, I'll show you how to use both of them. What you need to specify in order to connect in to a running Docker instance is localhost, comma, and then the name of the port or the number of the port, which in this case is 1433. We're going to select SQL Server Authentication, and we're going to give it the password that we supplied in the Docker file. And let's connect in. And what should happen, yeah, it does, thankfully, is we connected into our SQL Server instance. And if we expand databases, you will see that we do actually have system databases, but they are system databases that we're not going to use. We don't have a database for our application, but we will create that later. So that's Management Studio, which I'm going to use going forward in this video because I just like it. If you don't want to install that, or you're running on Linux or Mac, then you can install this little plugin here. Let me just get rid of this, remove. And once you've installed it again, come over to your extensions, type in SQL Server, and I think it's this one here. Yeah, so I've got it installed already. So this one here, yeah, it's pretty good. It's a bit more basic than the Management Studio, as I say, but if you come over to it, just add a connection, type in localhost, comma 1433. Database to connect into, we don't have any yet, so just hit enter. We're going to use SQL Server rather than Windows. We're going to use SA as the password, and then just the password. Do we want to save it? Yes, let's save it. And then an optional name for the connection. No, we don't want one. And that will go away and it will connect in. And you can see here, it gives us a similar sort of view. It doesn't give you as many options as Management Studio, but it gives you enough to get you up and running. So that's it. That's us all up and running with SQL Server in Docker. Just remember, you need to run Docker before it will work. Let's come back over to our terminal. And again, remember to stop it, Docker compose stop to stop it if you want to do that. I'm just going to leave it running in the background for the rest of this tutorial, unless I have to stop it for some reason. But for the moment, I'm going to leave it running. So that's it. That's this section done. I think we're ready now to move on to actually starting to code up our GraphQL API. All right, so in this section, we're going to start coding. So let's move over to our startup class, and we're going to begin in here. Now, the first thing we're going to actually set up is access to the .NET configuration layer. Now, the reason we need access to that is because we need to read in config, and specifically, we need to read in a connection string that will allow us to connect to our database at some point. And we're going to store that in one of the app settings JSON files, and the .NET configuration layer gives us access to those files, as well as some other sources, which we're probably not going to use. But nonetheless, it gives us this nice layer of abstraction on top of all these configuration sources, and we can just read in config in that way. It's really quite nice. Now, in order to get access to that, we're going to access something called iConfiguration, and we need to use something called dependency injection in order to set all this up. So the way we do that is by defining a class constructor for our startup class. And into this, we're going to expect an instance of I configuration. And we'll call that configuration. Now, this is something called constructor dependency injection. If you've not heard of dependency injection or you've never used it, it can be a little bit confusing, but don't worry, we're going to explain it. And if you still don't get it after that, that's okay as well. The more you use it, the more it will eventually resonate and you will understand it. The reason I'm focusing in on it is because it's used so much throughout, not just this application, but pretty much every .NET application you're going to see. So it's worth covering in some detail. Now, the thing I struggled with when starting out with dependency injection was, okay, when we call this constructor, where do we actually get, where does this value come from? And that's really the whole point of dependency injection. That system takes care of the where does it come from? And we'll explain that in a bit more detail a little bit later. But just trust me for the moment, we are going to get something injected in here at runtime. And then we need to do something with it. So we're going to assign it to something. So I'm going to assign it to something I'm going to call configuration. Well, just call it configuration. And it's auto-correcting. So let's just take out that binder. So I'm going to assign it to this. And this, as yet, does not exist. And what this is basically, it's just going to be a read-only field. Okay? So what I did there was place my cursor in the complaining artifact, hold down Control and period, and that gave us that list. And I selected read-only field, which it has generated for us. Okay, and the value that gets injected here is obviously eventually assigned here, and we can then use this configuration throughout the rest of our class. So we go get access to it, and we can access all the methods on it. Now we'll do that later. We're not going to do that just yet. So that's all the code that we need to set up in order to get access to this configuration object. But I think it's worth spending a little bit of time on just how that actually works. And I'm going to move over to some slides now and we'll take a look at that. All right, so let's just move over to my slide deck, and we're going to talk a bit about dependency injection. So the first thing probably actually it's worth addressing is why use it? What problem is it trying to solve? It's not just something that you just do for the sake of it. There is a reason for using dependency injection. So the real reason is maintainability. It allows our code to be more maintainable. And how does it achieve that? Well, it achieves that by reducing what's called coupling between our components or between our classes. So that still doesn't make sense. Let's step through an example. So without dependency injection, you would have a situation where you'll have one class, which is a fairly common situation, and that class needs to use a second class for some reason. Doesn't really matter why. And straight away, that sets up a dependency between these two classes. Class 1 depends on class 2, basically. And what you would typically see and how you would set that up in code within class 1 is you declare a new object, and then you'd use the new keyword, and then you'd specify the class that it needed to use. Which all sounds perfectly reasonable, and if you're writing really small applications with not that many classes, to be honest with you, it's perfectly acceptable. But nonetheless, that's what we call tightly coupled. And the reason we say that is, if we then suddenly decide that class 2 is no longer appropriate and we want to use some other implementation, what we would then have to do is we would have to go through every class that used it and effectively rewrite this code or replace, this, class 2 with class 3. Now that might not sound like a huge deal, but if you think of a really large application with many classes and many classes using each other, many dependencies, it can get quite complex and you'll end up with broken dependencies not being able to be resolved, and it gets quite ugly, to be honest with you. So that is what we're trying to avoid. And dependency injection helps us avoid that. So let's look at an example with dependency injection. So again, we have the same class, but instead of telling class 1 that we need to use an actual implementation, in our last example, class 2, all we're telling it to use is an interface. Now an interface, you can describe it in a number of ways. It really just describes a contract of operations or methods that it is going to provide once it has been implemented by something, okay? And class 1 is oblivious to what is actually going to implement the interface. All it really cares about is that something will fulfill that interface at some point. That's all it cares about. Now, you might still ask the question, okay, well, there's still a dependency here. Well, sort of, but not really. So let's take it a bit further. So instead of writing code like this, where you new up an instance of interface 2, which actually wouldn't work anyway, you'd get a syntax error. What we do instead is, and this is what you saw in the code example, we would create a constructor for our class 1, and we would say as part of class 1 being set up or constructed, we are going to expect interface 2 from somewhere. And then it's the job of the dependency injection system to provide a concrete instance for interface 2. That's the whole point of it. And so yes, there we go. In the example, the DI system will inject a concrete class, in this case class 2, into my dependency parameter. Now your next question is going to be, how does it know that we want class 2 and not something else? Well, that brings us on to the topic of something that we call the service container. Now all the service container does is map those associations between your interface and the implementation class, in this case class 2. So at the point where we request interface 2, we look to the service container and we see that yes, we have to provide an instance of class 2. Now the service container, we set that up, we set these mappings up from within the configure services method of the startup class, which is probably going to bring you on to another question in relation to our code, but I'll cover that in a second. The code we've set up for iConfiguration is a slightly different edge case, and I'll come on to that in a bit as to the reason why. But coming back to this instance here, slightly simpler example, if we then decide that class 2 is no longer the implementation that we want to use, and we want to use something else, all we simply do is tell the service container to change that mapping. And at the point where we construct class 1, the new concrete class will be injected at that point. So that's where the concrete classes come from. All right, so let's just summarize it, and I've got another bit of a worked example. So in the case of .NET 5, the default service container is called iServiceProvider, and here's just a little bit more of an example, which is basically just the same information on the previous screen. We will define the interface, or you can actually define a base class as well. So whenever we're asked for any of these things, this is the implementation that we give out at the point they are requested. And that can be at the point when the class is constructed. There are other ways you can inject dependencies, but we'll cover that a bit later when we come to the code. So just to summarize, yes, there we go. Configure services in our startup class is where you typically configure the service container. So let's just go through a few bullet points. Yes, dependency injection, we use an interface. That should actually be OR base class, just correct that. So we use an interface OR base class to abstract the dependency implementation, which we've sort of talked about. Registration of the dependency is in a service container. In the case of ASP.NET, it's iServiceProvider, and it's usually through the configure services method, and I will emphasize the word usually. The service or dependency is then injected into the constructor of the class where it's being used. Not always, we can inject it in other places, as I've said, but for the most part, it's the constructor. And then just a little bit of extra detail, the DI framework is responsible for creating an instance of the dependency and disposing of it. And that's referred to as a service lifetime, and we'll maybe talk a bit about that later. Now, you're probably going to have a question then, if we come back to our code and we look at it, and we go, okay, that's all really cool and everything, but in our configure services method, there isn't anything, it's empty. So I'm still confused as to how we know where iConfiguration, in this case, is coming from. Well, that is a fantastic question, and it just so happens I have a slide that answers it. There are some services that are injected into the startup class, or can be injected into the startup class without needing to register them within configure services. And as it says there, only the following services can be injected into the startup constructor when we're using the default iHost builder. Now that iHost builder is actually in our program class. So we're not really touching that class, but because we're using the default iHost builder, it provides it actually registers 3 services for us already that we don't need to register ourselves in configure services. And they are iWeb host environment, iHost environment, and iConfiguration. Okay, so it's kind of taking care of that step for us. In every other instance where we're using dependency injection, we will need to register the services with the service container from within the configure services method, and you'll see that as we move through the rest of the course. So again, here's the code we've already pretty much written, and yes, iConfiguration in the startup constructor, and it's just injected at runtime without us having to do anything else. So it's a little bit of an edge case, a bit of a weird one to start with, but it was the first code that we needed to write that required dependency injection. So that's it for the slideware. That's really it for this section. That's it for the code. All we really need to do is let's just do a .NET build, just to make sure everything's looking okay. Actually, let's save that first. And let's do a .NET build. And yes, there we go, we get 0 warnings. So that's cool. We will now move on to the next section where at some point we will make use of our configuration layer. All right, so in this section, it's a short section, we're just going to set up the first of 2 models in our application. So we're going to set up our platform model here, and it's really I'm going to call it our primary model, and we're going to have a child commands model that will relate to it at some point in time. So back in our project, just click in the root of our project, and we'll do a new folder, and we're going to call it models. And into that, you'll right click, new file, and we're going to call it platform singular.cs. Now this is probably about as simple a class as you're going to get, so nothing too challenging in here. So namespace, command.gql, and it's in our models namespace. And then it's just a public class called platform. Okay. And our class is going to have a number of properties. So to define properties, you can kind of do it in a shortcut kind of fashion. If you just type prop and then tab, that brings up this kind of template. And the first property that we are going to define is in fact an integer. So you just tab over and give it a name. And we're going to call this ID, which unsurprisingly is the ID of this particular class. The next property is actually going to be a string, and we're just going to call that name. And that's just going to be the name of our platform, whatever we choose that to be. So .NET, Docker, Ubuntu, doesn't really matter. And then the final property we're going to set up, I'm just including this just to provide an example for something that's going to come into play a bit later down the line. So you might go, why are you adding this in here? It will become clear a bit later on. But we're going to add another string property, and we're going to call it license key. All right, now we're not quite done yet, because what we want to do is we want to define some annotations or characteristics on these properties. So when we push this down to our database, which is called the migration, I'll cover that a bit later, we want to basically tell our database how we want this data to be stored and any rules around it. And beyond that, not just at the database level, from an application level, we want to provide these annotations as well, so that we know what constraints, if any, we have on these properties. So the first one I'm going to define is key, which basically says this attribute is a key, not surprisingly. Now we probably don't actually need to do that. Entity Framework kind of takes care of that for us, but from a non-database perspective, it's probably worth having that in here. Now you'll see it's complaining, and all we do is control period, making sure the cursor is in the offending article, and it will give us a list of resolutions, and we just want to bring in this namespace component model annotations. And the only other one we want is to specify that our name attribute is required. Okay, so it cannot be null. And then license key can be null, because some of our platforms may or may not have license keys. And to be honest with you, that's about it. That's all we need to do for our platform model. We will be building more later, and we will be adding to this as we move through the course. But for now, that's our first platform model done, and that's this section done as well. Okay, in this section we're going to set up our DbContext. So what it might be worth doing actually is just doing a little bit of an architecture revision of our application architecture, just to kind of review where we're at. So we have a program class, we have our startup class, which we will continue to work with. We do have a request pipeline. We've not yet added either GraphQL or WebSockets to it, so just ignore that for the moment. We've set up our first model, our platform model, and now we're coming on to the data access class, or the DbContext, which is really part of this thing called Entity Framework. And all Entity Framework is something called an object relational mapper, and what that allows us to do effectively is map our internal data or models down to a persistence layer. In this case, we've chosen SQL Server, and the DbContext basically acts as that mediator. It almost acts as an in-application representation of the database, and it maps our models down to the database. So that's where we're at. This is what we're going to focus on as part of this section. And just to labour the point, if it wasn't clear already, what we've done so far, and indeed what we're going to do in this section, really doesn't have anything directly to do with GraphQL. That comes a bit later. You would be doing this exact same stuff if you were writing a REST API or some other application in .NET that needed to access a database. This is non-GraphQL stuff just at this point, totally generic. Cool, so let's come back over to our application, and we're going to put our DbContext into a different folder. And so new folder in the root of our project, and I'm going to put it in a folder called data. And then in our data folder, I'm going to right click that and do new file, and I'm just going to call it app dbcontext.cs. All right. So again, let's define the namespace, which is command or GQL, and this time it's data. And I'm actually we're going to bring in some namespaces, but I'm just going to actually manually put these in at the top, because it's just going to make the flow of the code I'm going to type out a little nicer. So the first namespace we need is Microsoft Entity Framework Core, because we're going to inherit from a base class called DbContext, and that is where we can reference that from. And the other thing we're actually going to reference is one of our internal areas or internal namespaces, so command or GQL and models, because we're going to actually make use of our platform model, and you'll see how that manifests in a minute. So we are going to define a public class, app DbContext, and as I said, we're going to inherit from a base class called DbContext. Okay. And again, remember back to when we talked about dependency injection, we talked about interfaces, we also talked about base classes. This is basically a base class, and you'll see how this manifests later. And in fact, the DbContext is something that we inject all over the place throughout this application. So just stick a pin in that, but bear it in mind. And then we're actually going to specify as well a class constructor, so public, and then just give it the name of the class, app DbContext. And we're going to expect some DbContext options, and we'll just call that options. And then we're going to use this base keyword, and we're going to pass in those options to the base class effectively. And that's all we need to do at this point in time. So because we're inheriting from a base class, we do need to put this constructor in, so that if we do want to pass stuff into the constructor is already there for us. And then all we need to do is set up a property. So prop tab. Now this time, the type of property is going to be something called a DB set. Now what's a DB set? A DB set is basically a representation of our model in the database. So think about the DbContext as the database, and think about the DB set as the table in the database. Okay, it's basically that simple. So we need to specify a type, and the type is, any guesses? Platform. Okay, so a DB set that's going to mirror or represent our platform model down in our database. And the convention will be to name it, give it the same name, but to pluralize it. So our model is singular, our DB set is pluralized, so platforms. And that's basically it for our DbContext, but we're not quite finished yet. So let's just do a quick .NET build just to check that we're all on track and there's no errors hanging around. Okay, so that's all good, but we're not quite finished with our DbContext yet. We have two other steps to perform. The first one is to provide a connection string that it can use, which basically tells it where the database server is that we're going to connect into. And then we need to register it for dependency injection in configure services. So let's do the connection string first. Now, as I've said previously, we can provide that anywhere that the configuration system allows us to access, but I'm going to use, and quite logically I think I'm going to use app settings development JSON, which is basically a configuration file, not surprisingly, specifically for use within the development environment. So within the file, it's just a JSON file. Make sure you put a comma, and then we're going to specify a new area. And you can see here, we're actually being provided with a suggestion, and I'm going to take that suggestion, which is connection strings. And if you follow this format, it just makes subsequent code a lot cleaner, and I'll call that out when we come to it. So I really recommend you use this particular naming convention. And then we're just going to specify our connection string. But first, as per JSON, we need to give it a name, so anything you like. So we'll call it command con string, doesn't really matter. And then colon, and then we actually specify our connection string. Now, this is a connection string for SQL Server. If you've decided to use a different database platform, you'll need to do a bit of Googling to find out what the format of that system's connection string would be. But as we're using SQL Server, this is what we're going to be using. So the first parameter is server, which not surprisingly tells us where our database server is located. And for us, it's just localhost 1433. Now, you'll have seen this before when we actually connected into our database. If you remember, this is our database server. We don't have any databases on it yet. We just have the server. So that's all this is specifying. So semicolon, and then the next parameter, not surprisingly, is what database do we want to use. So we give it any name, commands DB. Now, this database doesn't exist yet. And it's only when we come to migrating all this down to the server that the database will get created. But then subsequently, when we connect in, this is the database that we'll use. Cool. So then the next thing we want to specify is the user ID we're going to connect in with. And I'm just going to use the SA account that we've used to connect in. And then the last parameter that we should be specifying is the password. Now, just a word of warning here. Typically, you wouldn't specify your password in a settings JSON file like this for obvious reasons. If you commit the code up to GitHub, it's readable and all that kind of stuff. But for our purposes, it's fine. If you want to remove sensitive information like this from something like app settings JSON, you would then use another component of the configuration framework, such as user secrets, and that basically stores sensitive information like that away. Now, I've done lots of other videos on that. I'll put a link to videos that I've already done that explain how to do that. But in the interest of moving this along, I'm not going to do that here. And that's basically it. That's our connection string set up. And then the last thing we want to do to round off DbContext is to come back into startup class and to register it in here as a service. So the way we do that is by making reference to services here, and we will request that we add a DbContext. Now, this is registering basically our DbContext with our service container. And so we're saying we want to add a DbContext, and then we have to specify, well, basically an implementation, and we're going to specify our implementation here, which is app DbContext. Now, it'll complain because it doesn't know where that is yet. We need to bring in that namespace, but we'll do that in a second. And then we want to pass over, using a lambda expression, we want to pass over some options. And the first one we want to specify is the use of SQL Server. There we go. And let's take a new line. Now, this is where we actually make use of our configuration object that we set up earlier on. So configuration, connection string, and then all we simply do is specify, I'm just going to close this out, the name of our connection string, which is this here. Now, because we used this naming convention, connection strings, what that means is we actually have access to this get connection string method. That's basically where the payoff comes. If you didn't use that naming convention, you could still access your connection string in the file, but you'd have to use a kind of long-winded convention to get to it. So still complaining about an app DbContext, let's just do a control period to bring that in. And that brings in that namespace. Now, it may also have been the case when I was maybe playing about earlier. I think it might have been this namespace here that generally doesn't come by default. Yes, so you may, if when you're doing this, you may get an error under use SQL Server, and again, control period to bring in the relevant namespace, which I already had up here. So just make sure that you don't worry if you got that. It's just because I had the namespace included already. Cool, so that is basically our DbContext setup. We've set up our connection string, and we've now registered our DbContext within our configure services method, so it's now registered in the service container. So all that really remains to do, insofar as this kind of rough area or this rough section, is to now migrate all this stuff down to our database and see if everything that we've done has actually worked. Okay, so in this section, we are going to migrate what we have done down into our SQL Server instance. Now, if you don't know what migration is, basically the situation we're in now is that we have our code basically, so we have our platform in code, we have our DbContext, we even have our connection string, and yes, we have our SQL Server, but they're kind of still a bit disconnected. So what the act of migration is doing is basically saying, okay, we've got our platform model now, we want to now represent that in the database, and we do that through a process called migrations. So that's what we're going to generate now, or that's what we're going to do now, and it's a kind of two-step process. But just before we go on to doing that, we just need to check that we have one tool set, or one set of tools installed, which are the entity framework tools for the .NET CLI. That's a bit of a mouthful. And the way to check to see that you have those installed is .NET EF. And if you have them installed, then you should see something similar to this here. Yeah, so a little unicorn and some information about it. Now, if you don't get that, then what you need to do is install those, and there's a number of ways that you can install it. But the way I'd recommend is to install it in this way. So you type .NET tool update global, make sure you spell global correctly, global .NET EF, okay, and that will actually install, that's if you want to update. So if you don't have them, and you get an error when you ran .NET EF and it said, I don't know what you're talking about, to install them from fresh, this is the command you would use. You may encounter a scenario where you have them installed, but the .NET toolset actually recommends that you have to upgrade them to the latest version, in which case it's exactly the same command, but instead of install, it's just as I typed there, which I'm used to doing, hence why I typed it, is this here, .NET tool update, and that will just update it. In fact, if we run that now, it'll probably just say we didn't need to do anything. Yeah, there we go. .NET EF was reinstalled with the latest stable version. So I was already at 5.02 anyway, but that's all good. Shows you it kind of working. All right, so using .NET EF, the first thing we want to do is generate a migrations file so we can take a look at it and see what it's going to do before we actually execute it. And the way you do that is, yes, .NET EF, migrations, add, and then you just give the file a name. So I'm just going to call this add platform to DB. Call it anything you like really, but it's probably better practice to give it a name that kind of sort of describes what you're intending it to do. So in this case, we're adding a platform model to our database. So hit enter, and what that will do is it'll actually do a build, a .NET build. And hopefully if that succeeds, which it has done, it's succeeded by the looks of it. Now what you will see, for those of you who are keen of eye, you will see that a folder called Migrations has been created up here, and we have a number of files in it. Now the only one we're really interested in is this top one here, which basically describes what is going to happen when we effectively execute this file. And you can see it's time-stamped and all that kind of stuff. Now what it's got two methods, an up method and a down method. And now the up method is used for creating stuff, and the down method is used for kind of rolling back changes, which you can do with migrations. It's quite a powerful system. So you can see here we're going to create a table. The table is going to be called platforms, and that's really been lifted from here in our DbContext. Okay, and then it's going to create a number of columns, an ID column, which is also going to be an identity, a SQL Server identity, with a seed of 1 and an increment of 1, a name column of type string, it's specifying it as an nvar char, nullable is false, so we have to have that, and then finally license key, which is this kind of weird property we've specified for a use case later down the track, and that can be nullable. So that all looks good. I would suggest whenever you're migrating stuff down that you take a quick look at the migrations file and just give it the once over, because sometimes it's usually pretty good, but sometimes it can do some kind of weird stuff, especially as you get more complex. So that all looks good to me. So we'll just close that down. And then just to labour the point, if we come back over to here, you'll see, and we refresh this, you'll see that just because of, run that step and generated a migration file, it's not done anything. There's no database here yet. That happens in this final step. And that's simply, again, .NET EF, not ED, EF, database update. And that actually executes the changes that we want. Now, if you're using, while that's happening, if you're, excuse me, if you're using Visual Studio, then you'll have to issue these commands using the Package Manager console, and they are slightly different. I will put what those commands are in the appropriate resource section of the video, and you can check those out. But that was good. So again, it runs a build, which we expected it to succeed anyway, but it looks like the actual migration step was successful as well. And the easiest way to check that is just to refresh our databases. And you can see, yep, indeed we have commands DB created. And again, just to remind you where that came from, that's when we specified the name of the database in our connection string. And then if you look a little bit further, we should have two tables. There's one table called EF Migrations History, which is used by Entity Frameworks, so we don't need to really bother about that. But the one we are interested in is this platforms table. And if we expand it a bit further, you can see what columns it has. It's got an ID column, a name column, a license key, which looks pretty good. So that's modeling, no pun intended, that's mirroring, maybe that's a better expression, mirroring what we have in our actual code class. Cool, so that's really the fabric of our data sort of base connection type stuff set up. So if we just review our architecture, I think we're in a pretty good shape. So we've set up our model, we've set up our DbContext, we've registered it in our startup class, so it's available when we need to use it elsewhere in an application. So yes, we are basically done with this kind of section and we're ready to move on. All right, so in this section, this is where it starts to get interesting. Well, hopefully you found it interesting so far, but this is where we're going to dive into GraphQL proper. So over in our project, just right click in the root of the project, and we're going to create a new folder, and we're going to create a new folder that's going to hold all our GraphQL artifacts. And we're just going to call that GraphQL. Now actually, before we even begin coding, it might be worth just revisiting our architecture, although we've just gone over this in the last section. I just want to take you through what we're actually going to build now. So this is what we did in the last section, as you've just seen. But now we're actually going to introduce a query object or a query type as part of our schema into GraphQL. And as I said in the the overview of GraphQL, you need a query, a root query type entry point. It's mandatory, so that's where we're going to begin. And what we're going to do as we move through, we're going to use a client. We're going to use a couple of clients actually to query the API. So yes, I'll take you through that as well. HTTP post request comes through, hits the query. We're going to hit our DbContext and return the data back as a HTTP response. So we're going to set all this up in the next few sections. So let's get started. So yeah, back over here in the project, right click the folder and we'll do a new file and we're going to call it query.cs. And it's a relatively simple class, but there's a couple of interesting concepts in it nonetheless. So as usual, we'll introduce what namespace it's in. So it's in Commander GQL and it's in GraphQL. And then it's just a public class called query. So relatively straightforward so far. Now our query class is going to contain a number of methods that return an iQueryable result that relate to the things that we want to pull back. So just a number of methods. We're going to start with one, and this method we're going to return back all our platforms basically, but the stuff we did in the last section effectively. So public iQueryable, capitalize the Q. And as we don't have any namespaces at the top here, we're going to get lots of sort of errors. And it's going to expect to return platform. And we're going to call this method getPlatform. Now this naming convention is actually quite important. I'm not going to delve into it too much now. We'll cover it a bit later, but just use this convention for the moment. Get and the resource that you want to return back. Now, just coming back to the topic of dependency injection, with the Hot Chocolate framework, we've done something really interesting here, and they are allowing you to basically retrieve the DbContext service as part of this method call, rather than injecting it in through the class constructor. So we're going to follow their recommendation and their convention, and the way you do that is square brackets service, and you'll see when we bring in the namespace, you know, that this is actually coming from the Hot Chocolate framework, and then at DbContext, and just give it a name context. So the .NET dependency injection framework, it only supports constructor dependency injection, which I kind of showed you in the slide, where this is kind of something slightly different. You're allowing, I suppose, effectively a dependency to be injected through the method, which is a valid approach, by the way. You can, you know, other frameworks do support that out of the box. So we're getting that with Hot Chocolate, which I think is quite interesting. And then let's just clear up the errors we've got. So we're going to bring in the link namespace. So again, place your cursor, control and period. So using link. We're going to bring in our platform model. Cool. We're going to bring in this service concept, and you can see it's actually coming from the Hot Chocolate framework. And then finally, we're going to bring in the DbContext reference, or namespace, should I say. And this is erroring out, obviously, because it's not yet returning anything, and it's really, really simple. You just return the DbContext, and we're going to return the platforms, basically. So just remembering back over here in data, DbContext is basically just using the DB set. That's it, really. So that's it for our query at this point in time. It will get slightly more complex as we move through our examples, but for now that is sufficient. But we're not done yet with wiring up GraphQL. We have to now, not surprisingly, move over to our startup class and add a few things in here. So what we're going to do in the startup class is we're going to, not surprisingly, work within our configure services method to set up some services. And we're also going to set up our request pipeline in the configure method. But let's focus on the configure services method for the moment. And we're going to add 2 services as part of this section. And the first thing we're going to add is this add GraphQL server. And not surprisingly, that provides us with a server, and it also is really the entry point, or the beginning of our schema construction. So we're going to add multiple, we're going to chain multiple services here, which ultimately add up to a full schema at the end of the day. The first thing we need to do is add the GraphQL server. And then the next thing we need to add is the query. So add query type. And we talked a lot about types in the introduction to GraphQL, so we're going to specify that this is of type query, which is just the query class that we created just a few minutes ago. And just close that out with some round brackets, and I'll need to bring in that namespace, which is Commander GQL GraphQL. And that's it for the moment. I mean, this will get more complex as we move through our examples, but for now, that's all we need to do in configure services. Now, the next thing we need to turn our attention to is the request pipeline. So perhaps if we just come back to our architecture, you're probably sick of seeing this now, but I think it's good as a reference point. We need to add GraphQL to our pipeline. So let's just clear that down for the moment. And the way we do that is within our endpoint section. So we're going to add an endpoint effectively. So we can take this pre-canned stuff out. So this was added as part of the project scaffold. So we can just take that out. And all we need to do is just make use of this endpoints lambda expression. And all we do is just say map GraphQL. It's pretty much that easy. It's not really anything more difficult than that. So that is basically it. So let's do a quick .NET build, just to make sure we don't have any gremlins hanging around, and that all looks good. So we're kind of done for the coding in this section. So in the next section, I'm going to take you through how to run this up, although that's quite easy, obviously, and we're going to start using some querying tools to actually play and run with this API. Okay, so we're going to run up our API now and pull back some data, hopefully if we've done everything correctly. But just before we do that, a couple of things. Just make sure, because you might be stopping and starting this tutorial as it is quite long, just make sure that your SQL Server is available and running. I sometimes forget to, if I'm restarting again at a certain point, I sometimes forget to restart the SQL Server. So make sure it's there. And the other thing we want to do, and I can't remember, I'm losing my mind a little bit, I can't remember if we actually put any data into our database. So let's take a look. I don't think we did. So let's look at our platforms table, and we can do edit top 200 rows. And we don't have any data in there. So let's put some in, which would be quite useful. So let's put in .NET 5. Actually, we should probably write it like this. I'm just so used to typing .NET at the command line, that's how I type it, .NET 5, Docker. And let's pick something like Windows. And we'll put in some junk license key. I presume that's a junk license key, cool. And let's kill that, and let's query it to make sure it's in there. So select everything from platforms. And platforms is a reserved keyword in SQL Server anyway, so we put square brackets around it to kind of delimit it or whatever. So that's cool, the data is in there. If you want to understand how to put data in using SQL, you can do something, well, you do use an insert statement, so insert into, and the table will be platforms, and we specify the columns. We don't specify the ID because that's auto-generated, so name, cool, and that's it. We'll just put the name in actually, and then values, we'll just put test. Should be fine. So I think that's right. I'm doing this kind of from memory. Actually, let's run both these. There you go. So it's inserted, you know, this test entry in, and I'm going to delete it because I don't want something. The data is pretty rubbish, but I don't want it that rubbish, so delete from platforms where ID equals 5. There we go, that's gone. There we are, get rid of that. Cool, so yeah, SQL Server's running, we've got some data in there. Let's run up our API now. So .NET run to run it up. And you can see here, because we've not changed anything, we just get the standard port 5000 and 5001 for HTTPS, and that comes from this launch settings JSON file, which has a number of kind of, I suppose you call them profiles, depending on which environment you're using. As we are using the .NET CLI, this is the profile that gets picked, and this is the application URL. Great, so let's run up a new instance of Edge. And I'm just going to browse to our endpoint. Oh yeah, so let's just come back here. Over in our configure method, we configured our request pipeline and we added a new endpoint, this one here. And that basically equates to the following. So HTTP, localhost, in fact, let's remember that from when I'm testing it, but I'll just show you a bit more step-by-step fashion. That's the server, and then we just type in /GraphQL to hit that endpoint that we specified. Now, just a bit of a FYI, typically on my travels, when you're querying GraphQL APIs, this is the the standard format. Generally, you'll have the URL to the server. It might be a bit longer than just, localhost port 5000, might be a bit longer than that. But always the GraphQL endpoint is typically /GraphQL. And that's what you will use to query against. But because we were using the Hot Chocolate framework, they very kindly provided us with an additional graphical user interface that we can use to actually run some queries. Now, this is called Banana Cake Pop, which is a bit of a strange name. The tool's absolutely decent. I'm going to use it on and off throughout the tutorial, but I'm going to use a tool called Insomnia, just purely personal preference. I actually like it though because it gives you some, I suppose you'd call it IntelliSense type functionality that this kind of gives you, but not in the same way. So there's a couple of buttons here. There's you can generate queries from here, but we can also look at the schema that's been pulled down, and you can see here that we have a query and a query type, and it has this platform query in here that returns an array of platforms. Now this platform query just relates basically to this query here. Now, as I mentioned, we use this get platform syntax. You'll notice that the word get doesn't actually appear as in terms of the name of the query. It's omitted. If we decided to call this something else, in fact, let's do this, say blah, Control C, sorry, to close that down. Let's run it up again and come back to our endpoint and refresh. Now, I do find with this tool, one of the things you do have to do quite frequently is refresh the schema. Did I save it? I didn't save it. There you go. That's why it's not working. So let's save that first. Let's run it up again. That's another hot tip. Make sure you save everything you do. Otherwise, you're going to look foolish like I did there. So let's just pull up this and let's refresh it. There you go. So you can see it's now called blah platform, which is obviously something we don't want. So again, just a naming convention. Call it get platform, and then it just uses whatever follows that. Save that this time. Control C, let's run up again. And we'll do a quick refresh of the schema. And it should be back to platform. So that's basically showing us, platform, and it allows us to navigate and have a look at the object attributes or fields as they're called here. And we can see, what types they are as well, which is good, and whether they're nullable or not, which is great. And the one thing that is missing here that we will add later is documentation. So one of the things I love about GraphQL is you can actually add documentational elements to your classes, and that will then appear as part of the schema. So as a developer, you don't have to refer to other documentation. It's kind of in line with the API, so it's very cool, and we'll do that a bit later. But anyway, back to this tool, and let's come back to the query window, and we're going to actually run a query now. So in the language we're actually using here is the GraphQL query language. So I'm going to say we want to run a query, curly brackets, and then if we had more than one query type, we could select whatever query we wanted, but we only have one, which is the platform query. And then again, we're going to open some curly brackets, and then again, one of the strong points of GraphQL is you can specify the fields that you want returned, and I just want name and ID. I'm not going to bring back the license key. So let's run that, and this is the moment of truth. If we've done everything correctly, there we go. We will bring back I'm just being thrown because I'm seeing this test one here. Maybe I used the wrong ID. Is that what I did? Yeah, should have been delete ID 4, not 5. Okay, doesn't really matter. So yeah, we brought back our 4 platform objects from within GraphQL. So that's all looking really, really good. Now, as I say, I'm not going to use this for the most part. I'm going to use this tool called Insomnia. And it gets entirely up to you whether you want to use this or not, but I just find it is a very decent tool. Now, this is something else I was playing with. So the thing I like about this, you can create a number of workspaces, which I'm going to do now. And a workspace is basically, if you have a, like myself here, this is a work-related workspace, I will use it for that. And if this is my YouTube-related workspace, I can create that. So yeah, let's call this my YouTube workspace. It's a good one as any. and it kind of empties out your workspace, so it's completely empty. And then there's this concept of environments, and that's useful when you have multiple environments. So say you have a production environment and a development environment and a test environment and a production replica environment, and they all require maybe different API keys to authenticate through. You can set that all up in your environments. Not going to cover that today, but it's a really nice feature. So in this workspace, you just right click, you do new request, and we'll just call it, let's call it get platforms. And it's a post request. So pretty much all, certainly as far as I've seen, all requests that you make to GraphQL are usually post requests. And the body is GraphQL, okay? And we'll just create that. Now you can see here, we're already getting an error. Now that basically is saying that we don't know what the schema is. Insomnia tries to go away and get the schema, and as you can see up here, there isn't one. So let's just put that in, HTTP localhost 5000 GraphQL. And if we do a schema refresh, now we'll usually do this automatically, but we can force the issue as well. You can see that the error's gone, and that's kind of cool. And we might do this as we move through the video. We can set up variables and stuff when we come to doing more complex queries. But again, we're going to specify a query. And you can see this is why I like Insomnia, because straight away, it kind of gives you everything that you can do. It's really helping you along. It's really prompting you along. And if you're new to this, that's why I'm using it a lot. If you're new to the GraphQL query language, it comes in really useful. It kind of really helps you out a lot. That's not saying the other tool wasn't great, but I just found this one is a lot more kind of helps you along a bit more. But it's basically doing exactly the same thing. But the thing I like about this is that you can kind of see a bit behind the scenes. You can add headers. So if the API required a key, this is where you'd add it. Authentication is the same thing, but ultimately it's doing pretty much the same thing. You can view the documentation here as well. You can hover over the platform query. You can click on that and it will bring it up here. It returns a platform array or array of platforms and so on and so forth. Pretty much the same thing, doing the same thing, brings back the same result. So entirely up to you what you want to use, but for now, I'm going to stick with Insomnia. So that's our API up and running. We've added our first GraphQL query, which is awesome. In the next section, I'm going to show you one more tool that we're going to use, not really for querying, but more for navigating our schema. It's a visual tool that you can use to see what the schema looks like. Now, our schema is incredibly simple, so it's going to not look that impressive, but as we build it up and it becomes more complex, it's a very useful tool. So we're going to do that next. All right, so in this section, I promised you that we're going to use GraphQL Voyager, but let's just show you what that looks like. So forget our API for the moment. I'm just going to show you the tool, generally speaking. So open source, obviously, well, not obviously, it is open source. So if you just type in GraphQL Voyager, it should take you to the GitHub repo, and you can run a live demo. So let's do that. And I'm not sure what schema this is using, but you can change the schema. It might be it's the Star Wars schema. There you go. So let's display that. And what it basically does is you can kind of see here, it gives you a graphical representation of your objects, so your queries, all that kind of stuff. So we can look at this person object that's in this particular schema. So in our instance, it would be platform, and you can see all the attributes on it. You can see how it's related to other objects or other types within the schema. And for complex schemas with many, many types and objects and fields, this is a really great tool. And you can actually, click on things and it will give you more detail on, what each of these attributes is. And this is kind of the inline documentation that I was talking about. Highly recommend that you do that whenever you're developing an API. People using it will definitely thank you for it. Now, the thing to remember here is this schema that's being represented here is exactly the same schema that's being pulled in here, which is exactly the same schema that's been pulled into that other tool. It's just the same schema. And in the later section, I will actually show you how you can generate something called an introspection query, or run an introspection query that allows you to generate the schema and you can actually look at that. And so we'll do that in a later section down the line, if I remember. But for now, yeah, we're going to set up GraphQL Voyager in our project so we can use it going forward. So back to our project, I'm going to Control-C to kill that down for the moment, and we're going to come back to our startup class. Now, you'll just to remind you, back in our project file, our CS project file, we did add this package reference here, which is the reference you need if you want to use GraphQL Voyager. So that's already there. If you, for whatever reason, didn't add it, please add it now, otherwise it won't work, what we're going to do next. So all we really need to do is, within our configure method, we're just going to add it really to our request pipeline. And the way we do that is app, use GraphQL Voyager, new GraphQL Voyager options, GraphQL Voyager options. It needs us to bring in the namespace, and it's already kind of done that for us, but let's just take that out, and I'm going to pull that in up the top. I don't like doing it that way. I like it being as a using statement up at the top. It's much cleaner, I think. And then we're just going to basically specify the endpoint. Now, the reason I've kind of done it in this sequence is because we're specifying the GraphQL endpoint here, and you'll remember from when we actually used our GraphQL endpoint, all it was GraphQL. That's it. So that's all we have to specify here. And we don't need to put in the full, service name. It's just really the endpoint. It's intelligent enough to know that it's just, the / GraphQL component. And then the path to GraphQL Voyager, so when we want to run up, and you can obviously specify anything you like here. I'm just going to say / GraphQL Voyager. And that should be good. And I think we just need to close that off with a semicolon. So basically, we're just adding GraphQL Voyager to our request pipeline. So we're basically just telling it, again, just to repeat it myself, we're telling it where to grab the schema from. That's why we need to specify the GraphQL endpoint, so it can render that. And then we specify the path to where we will display GraphQL Voyager. Now, word of warning, it is going to look very basic at the moment. It's not going to look that impressive, but nonetheless, it will become more impressive as we build out our own schema. So .NET run, you have saved everything. Yep, cool. And then let's just come over here and do another new window, and we will just do localhost, and I'll just put in Voyager here. And hopefully, there we go, that looks familiar. There we go. So you can see straight away, actually, it's giving us some sort of value. So down here in this drop down, you can select the query, which is obviously the query type, or then the object. So we have query, platform query here as part of our kind of root query type, and it relates, this platform array here relates to the platform object that you've seen already with the attributes that you have. Now, pretty simple, but as we build this out, and even though we're going to only have two object types, platform and commands, they're going to have relationships between them. We're going to add not just queries, but something called mutations, which I think I've talked a bit about earlier, and also subscriptions as well. So this actually starts to become really useful. And again, you can also see here that both our query and our platform have no description, which is a really, really bad thing. And as a developer, you should be ashamed of yourself if you're putting an API into the world that has no description, especially when you can, no documentation, especially when you can add documentation kind of inline. So that's something we will cover off a bit later. But for now, that's this kind of section done. Our API, we've got GraphQL up and running. We have done our first query, and I've showed you some query tools. But something's wrong, something's not quite right, and I'm going to show you what's not quite right in the next section. All right, so I did just mention that there's something not quite right with the way that we have developed our API to date. Now again, here's the query that we've just been running. It's all working okay, but what I'm going to do is I'm going to take this query actually, I'm going to run it 3 times simultaneously, let's say, using concept called aliases within the GraphQL query language. So what an alias basically allows you to do is run a section of GraphQL code multiple times within the same execution sequence. And basically, what the GraphQL server tries to do is execute those multiple queries in as close to a parallel fashion as possible. It tries to do them all pretty much at the same time, and we'll see what happens when we attempt to do that. So it's a scenario that actually happens very frequently and very commonly within GraphQL, the more complex queries you have, and then especially when you come to querying child objects. So we're going to query our platforms, and then we're going to potentially query from our commands as well at the same time. This issue that you're going to see would actually manifest. So back over in Insomnia, I'm just going to do a new request, and I'm going to call it parallel platforms. Again, always a post request, GraphQL for the body, click create. We get this error because it doesn't have an endpoint, so I'm going to come back to our previous query and just copy that over and paste that in here. And I'll just do a schema refresh and the error's gone. Fantastic. So again, query. And when I'm talking about aliases, basically, it just allows you to give the query a name, basically. So I'm just going to call this first query A, and then it's just exactly what we have done before, a platform query, and then I'm going to select the ID and name. Now, if you run this, it's fine, no problem. In fact, it's pretty much identical to that. Okay, the only thing you can see differently in the return is we're getting this standard data return, but we're then getting the data set for A, which is the alias. So I'm just going to copy this, and I'm sure you're not going to be surprised what I'm going to call it. I'm going to call that B, and then we'll do it one more time, and we'll call the third one C. Okay, so we're just executing the same query basically 3 times. So the GraphQL server is going to attempt to do this pretty much at the same time. So let's see what we get. So straight away we're getting some errors. We're getting this unexpected execution error. We're getting it again. Then if we move down, we are getting data back, but for query A or alias A, we're getting nothing, we're getting null. Same with B, and then this time C is executing. Let's see if we run it again, what we get. This time, same sort of thing, we're getting 2 unexpected execution errors, but you can see this time we're getting nothing for A. We are getting a payload for B, and we're getting nothing for C. So it's a bit erratic, it's a bit all over the place, and we could run this multiple times and you would see that same pattern, different things being, one of the aliases would be successful and the other 2 would fail. And that's basically down to the fact that the DbContext we have used is not multi-threaded. So it gets fed this query by our GraphQL server, execution engine, and it's saying to it, here you go, here's execute these 3 things basically in parallel. And DbContext out the box cannot do that. It's not multi-threaded, and this is what you get. So don't worry, we can resolve this, and thankfully due to .NET 5, Microsoft have introduced a concept of a pooled DbContextFactory, which is what we're going to use next to resolve this error. And it's an error we definitely need to resolve because it's a very common use case from within GraphQL querying. You're going to be doing these kind of multiple queries simultaneously. I'll put that in air quotes. So yes, let's move on and fix this. All right, so in this section, we're going to fix up the issue we have with running this type of query, which is, a query that's almost attempting to be run in parallel, or 3 queries being run in parallel. So back over in our application, you can actually see that there were a number of errors thrown when we attempted to make the request in the last section. So should have probably shown you that. Let's just kill this and clear the screen. So we need to make some changes to our application. Now, interestingly, we don't have to make any changes to our DbContext, our app DbContext class. We can just leave that alone. But where we do need to make a change in 2 places. The first place is in our startup class. And we need to make a change to the way that we register our DbContext. So rather than using add DbContext, we register it using add pooled DbContextFactory. So if we actually hover over this, we can see what this is actually doing. So it registers an DbContextFactory in the service collection to allow us to create instances of a given DbContext type, where instances are pooled for reuse, which is exactly what we want to do. And then it just goes on to say registering a factory instead of registering the context type directly allows for easy creation of new DbContext instances. So that's all that's really happening here. We're just reusing the same DbContext from a kind of shared pool of resources. And so every time we need to make another query, it will just get pulled from this resource pool, as it were, and then return back when we no longer need it. So it's a really nice addition introduced with .NET 5 that we are definitely going to make use of here. So that's change number 1. And then change number 2 is over in our query class. And it's really, we need to tell our query method that we want to make use of this functionality, basically. And so in order to do that, we have to decorate this method with use DbContext, open brackets, type of, open brackets, and then just the name of our DbContext. And we need to pull in a namespace from Hot Chocolate, which is hotchocolate.data. Let's do that. And so basically what this is doing, it's saying that this particular method has to get a DbContext from the pool, execute the query, and then return the context back to the pool when it's finished. That's really all it's doing. And then here, we need to change this to say it's a scoped service. Now you might be going, what is a scoped service? Well, you may remember in our conversation about dependency injection, I mentioned this concept of service lifetimes. And this is really just talking to that idea. So if we actually, I've got a bit of a slide on this. If we just take a quick look at service lifetimes, we have this concept of a singleton, which is the same, use the same service for every request, which is not what we would want to do in this instance. Scoped, which is we create one per client request, and that's basically what we're saying here, that we want to have a scoped instance. And then there's this other concept of a transient instance, which is a new instance created every time, which is not what we want in this particular instance. So all we're doing back over in our code, all we're saying really is, yeah, in this case, we want a scoped instance. And that's it. So again, recap, over in startup class, we just need to add a pooled DbContextFactory, and then back in our query, decorate your method with this. And it's basically just telling the method how to make use of this concept of a pooled app DbContext, or a pooled DbContext, and then just specifying the service lifetime. So let's run this up again, .NET run, and we will attempt to execute our parallel query again. So was that running? Yes, it's running, cool. Had errors, let's, fingers crossed, try it this time. There we go. So we now get result set A, result set B, result set C. So basically using multiple pooled DbContexts. And that sets us up really well for moving forward with the rest of our API, especially in the next section, where we're talking about a multi-model approach. And in the next section, or next full part really, we're going to introduce this idea of another model. So let's move on to that. Okay, in this section, we're going to introduce the concept of our second model to our application, and that's going to be our command model. So far we have our platform model, which is our parent model, and our platform model can have no commands associated with it actually, or it can have one or more commands associated with it. And then when you look at a command object, when we build that, it can have one platform object associated to it. So we're going to introduce the command model as part of this, and then we'll need to make some other changes throughout the rest of our application. But let's set up our command model now, and we actually need to then go and look at our platform model and make a quick change there as well. So we'll do that in this section before we move on to changing our DbContext. So back over in our application, let's just stop this from running. And then over in our models folder, we're just going to right click, new file, and we're going to add a command.cs file. And then as usual, specify the namespace, commander GQL, and we're in the models folder. And it's just a public class called command. Autocorrect is great, but it can also be really annoying. So let's just take that out and make sure it's named correctly. Cool. So we're going to specify a number of properties. The first one shouldn't be a surprise. It's the ID, so int ID. Next one, prop tab is a string. And that's just our how how to. So basically, what does this command line do? Next prop, also a string, and it's basically the command line snippet, the actual thing that we want. And then we need to specify the relationship between our command and our platform. So another property, it's an integer, and this time you're specifying the platform ID, foreign key, effectively. And then we can also specify, and I'm going to do this, the actual model as well. Reference to the model, the platform model itself. And I'll just call that platform. Great. So that's basically our properties done. Now, as usual, we want to specify some attributes and annotations. So this one is a key. And we'll bring in the namespace, so control period to bring in the namespace. And then our how to attribute is definitely, or how to property is definitely required. So is our command line. And so is our platform ID. Cool. So looking at that, I think that's our command model done. So what we then need to do is actually come back to our platform model and kind of make the association the other way. We basically need to say that our platform model can have, well, 0 or more commands attached to it. So back over here, all we need to do is just specify another property. And this time it's an I collection of command objects. And we're just going to call that commands. And one thing we need to do is we just need to set that equal to a new list of command objects. And we need to bring in the collections namespace. So control period, system collections generic, and that should resolve our two issues. Fantastic. Okay, so hopefully that made sense. So that's our two models updated. So in the next section, we're going to update our DbContext. All right, so in this section, we're going to progress with adding our multi-model to our application, and we're going to update the DbContext. So over in our data folder, if we look at our DbContext, there's probably a very obvious change we need to make, and that's adding another DB set. So prop DB set. And we're going to add our command, and we're calling it commands. So we could leave it like that, and we could leave it to Entity Framework to determine the relationships that our two models have when we come to migrating them down to the database. And for the most part, that works really well. But what I've found from time to time is even just things like naming conventions, the way it will maybe name a table in the database is not how I want it to be named if you leave it to its own devices. Now you could go in to the migrations file and you could edit the migrations file and do things like that. I don't really like doing that. So instead what we're going to do is we're going to just specify in a little bit more detail the exact nature of the relationship between our two objects within our DbContext. And Entity Framework will use our instructions basically to build out the relationship exactly as we want them. So that's what we're going to do now. So a little bit laborious, but it's worth doing. So the way we do that is we override a method, which is the onModel creating method. So the way in which we do that is protected, override, void, and then it's onModel creating. And then we specify the model builder, and we'll just give that the name model builder. So the first relationship we're going to set up is from the perspective of the platform. So we'll make use of model builder, and we'll specify the entity. As I said, the entity we're working with to begin with is the platform. Don't forget the rounded brackets. And then we're going to start by saying it has many, and we'll use a lambda expression to specify this. There's many commands. Great, so nothing too controversial there. This one is a little bit more, it's a little bit weirder, but we need to specify its relationship almost with itself. So we'll say with one, we'll use a lambda expression again, and we'll say platform, and we'll just make that nullable. And then we then specify the foreign key has a foreign key. And again, use one final lambda expression. P goes to P platform ID. There we go. So that's it. Quite straightforward. And then we just specify using the same kind of construct, the same relationship, but going the other way from our command. So again, the entity we're specifying here is our command entity. And we're going to say it has one. Anybody guess what it has one of? That's right, it has one. Oh, not platform ID, it has one platform. And it has, with many, commands. I find this a little bit counterintuitive, to be honest with you, because we're defining the command relationships, so we're almost specifying the relationship as with itself, but nonetheless, that's what we have to do this two-way relationship. And then we say has foreign key, P goes to P platform ID. So it's exactly the same as what we have upstairs in this section here. So that's really it. That's our DbContext created. So when we migrate this down, the relationships will be set up accordingly. And also we have that, have these relationships from an application perspective as well. That's cool. So the next thing we really want to do is just migrate all this down to the database. So let's just do that now. So .NET, let's just clear this. So .NET EF. Migrations. Typing is getting worse as I get older. Add. And then we'll just say add command to DB. And we'll do a build to make sure everything is syntactically correct. So the build succeeded, that's good. And then in our migrations folder, we should see another file. So here we are. And we can kind of take a look at what it's doing. And again, I do recommend that you do this. So again, we're creating a table called commands, which is exactly what we want. And then, you've seen this other stuff before, the columns that we expect, and then we're adding this platform ID as a foreign key, and then you can start to see this is where we're specifying these relationships between the two tables. Cool, so I think that's everything that we need to do here. So looks good, looks okay. So the last thing we need to do, just clear the screen, is .NET EF database update. And all being well, it should migrate down, so that's a good sign. So we come back over to our database and we refresh our tables. Let's just minimize this. That's cool. So we have our tables. So we have a table called commands, a table called platforms. We have our columns in here, platform ID, which is all good. The other thing you can do here is we can create a database diagram. So the reason I'm going to do this, so database diagrams, new database diagram, and then hopefully we'll get the designer up. We'll just pick the tables that we want. The reason I'm doing this is just to sort of show you that this is the relationship that SQL Server thinks we have between the two, and it's exactly correct. It's exactly as we want it. Okay, so I'd like to do that just to check. So that's all looking really good. So in the next section, what does that mean for our existing query? Will that mean that we should be able to pull back commands now from our existing query? Maybe it does, maybe it doesn't. So in the next section, we're going to take a look at that. Okay, so in this section I said we're going to test our existing query and see how that works or how that doesn't work, or if we messed up or anything like that. So let's take a quick look at the query again. Come over here, and basically we're saying we're returning basically all our platforms. So I'm thinking maybe with the relationships that we've set up here, maybe it should be clever enough and intelligent enough to pull back our commands as well. So actually, just before we do that then, what might be worth doing is putting some data into our database. So let's just do that actually while I remember. So let's just refresh, do a new query and select everything from platforms, just to take a look at what we have in there. Now I'm going to definitely get rid of this test, which I should have done last time, which I made the mistake and used the wrong ID. So delete from platforms where ID equals 4, not 5. Okay, definitely gone. So we've only got 3 there, so that's good. So I'm going to add a couple of commands for .NET 5. Why not? So we'll be using this ID as the foreign key. So back over to our commands table. Let's edit the top 200 rows. Now again, you can use SQL statements, as I've shown you in one of the last sections, how to do this, but it's just a bit quicker to do it this way. So again, you don't put anything in ID because it's auto-populated. So I'm just going to say how to build a project. It's really simple stuff. Build a project, and the command line is .NET build, and the platform ID is 1, and then we'll say run a project, and it's .NET run, not ruin. Okay, cool. And then I think, what was Docker? Docker was ID 2. So for Docker, we'll say start a Docker compose file, and we'll say Docker compose up D, and that's platform 2. Okay, so again, we're not really, being super critical about the quality of the data we're putting in here, but it's really just for test purposes. But it's nice to have some data, so stop a Docker compose file. In fact, that's probably not particularly a very good description of what we're doing here. That's really stopping and starting Docker containers by using Docker compose, but anyway, we'll leave it like that just now. We can fix it up later. And that's stop, and that's 2. Okay, so we've got some data for our commands related to our platforms. Fantastic. All right, so let's do a .NET run. Everything's saved. Actually, before we do, I'm just going to clear down these windows just to give us a bit of room and make sure everything's been saved off, which it looks like it has. So let's .NET run this. Cool, and come back over to Insomnia, and I'm going to do a schema refresh. That's all good, and maybe what we'll do is we will create another, let's create another request, so new request, and we'll call it get platforms and commands, which again is one of the powers of GraphQL. You can have these nested objects with the one request, and it's really cool. So again, a post request, and it's a GraphQL query, so create that. Let's copy this from here, and we'll put that in here. Okay, so we're going to specify a query, and yep, a platform query hasn't changed, so it remains the same, but you can see now we have a commands collection here that we can iterate through and pull back our commands. So getting very exciting now. So we'll pull back the ID for our platform object, we'll pull back the name for our platform object, and then we'll go into our commands array, and we'll pull out the ID, and we'll pull out how to, and we'll pull out the command line. Fantastic. Okay, and let's see what we get. So, not quite what we were expecting. We do get back our platforms and we do get back our commands, but nothing there. Okay, so what's going on? Why are we not getting that data back? So we do need to make one change over in our query actually in order to allow it to pull back our commands. And that is, let me just stop that. Over here, we obviously have to keep this, but we need to decorate this with another attribute, and we're going to say use projection. What that means is it's basically saying, yes, you have to walk the graph to pull back any child objects that we have, because it's not really explicitly being declared here. So we're basically telling it, yeah, project forward and pull back any child objects. And now that's not the only place we need to add something. We need to come back over to our startup class. And I've mentioned this before, where we add our GraphQL type stuff, we're going to add multiple, we're going to chain multiple commands here or extension methods here to add various bits of functionality. So what we need to do after adding our query, we need to specify add projections. Okay, and that basically builds that in as part of our schema. Okay, so if we save that off now, so again, just to recap, we went into our query, we decorated our method with the use projections attribute, and then over in startup, we added projections as part of our configure services method. Now that's a very similar repeated pattern you're going to see from time to time. You'll typically add something to your query or your mutation, but you'll then have to add something here in configure services. And I always forget to put things in configure services, and it ultimately doesn't work. So let's try that again. Let's run this up again. And we come back over here, we'll run the exact same query. And I'm hoping we should see, there we go, we are getting data back. So it's starting to look a lot better now. So you can see down here for Windows, we're bringing back the Windows platform, but quite correctly, there are no commands. So it's just an empty array, which is exactly what we want. And then for our platforms, we're bringing back .NET 5, and then we have 2 commands, and then likewise for Docker. So we're really at quite a nice point in our querying where, you could almost say we're sort of done. But there's a lot more things we can do here to make it better, and we're going to cover that in the next sections. All right, so in the last section, we added a second model to our application, our commands model, which allowed us to retrieve those commands from within our platform query. We did have to make some changes to that. Now, before we do anything else, I thought it might be worthwhile to look at GraphQL Voyager, which was the tool we set up, the graphical tool we set up, and just see what our schema looks like now. So let's go back to localhost, GraphQL Voyager, and it should look a little bit different, yeah. So we have our command model in here now, and you can even see the relationships are mapped here as well, which is really, really nice. Now we still don't have descriptions on any of our fields or descriptions for our objects or anything like that, which we do need to rectify, but we'll cover that in a second. But as you can see here, we just have our one platform query. Now I want to add another query that will allow us to return our command objects back with the associated platform. So not terribly difficult, but I think it's useful to do just to embed how to do that. So let's kill our server from running, and let's come over to our query class where we have, you should be familiar with this is our platform query. We're going to add another query in here, and it will look incredibly similar. So iQueryable, and this time it's command we're bringing back, and we're going to call it get command. And I'm going to just say command, and I'm going to say it's a scoped service once again. And it's just an app context with the name of context. And then we're just going to return context, but this time we're returning our commands. So if we come back over here, we're just coming back to app context, and we're using this dataset commands to return that back. And of course, don't forget, we need to decorate the method with both these attributes to make use of our multi-threaded DbContext. So save that off, looks very familiar, and then let's just do a .NET run. And one thing we'll do is we'll come back to GraphQL Voyager and we'll refresh it, and we should see another query appear here. So again, just bear in mind what this is doing. This is going and getting the schema, and it's re-rendering what it thinks the schema is. And you can see here that, yeah, we have a new query called command, where we have an array of commands that will come back, and looks pretty promising. So back over in Insomnia, I'm going to write a new request. I'm just going to call it get commands. Of course, it's a post request. GraphQL is the body. We'll create that. We'll come back to one of our existing queries, do a schema refresh. All's good. And this time, if you type in query, you will see our command query has been added. And what does that look like? That allows us to retrieve our how-to, it allows us to retrieve our command line, and it will allow us to retrieve our platform. And we can then specify the name of our platform. So kind of the reverse of what we've already done, but depending on your use case, you might want to query this way. Run that, and again, yeah, there we do. So we've got all our commands this time. So no redundant data really. We're just bringing back commands, and of course they all have to have a platform. So it's different to this, where we brought back, not that one, this one here, where we did bring back, our commands, but they had no, sorry, we did bring back our platforms, but there was no commands in this instance. So, it depends what you're wanting to do. It depends on your use case, what you are trying to achieve. But that's cool. Wanted to do that just to show you how easy it is to add another query in. So we're going to discuss documentation next. Okay, in this section we're going to talk a little bit about how you document your APIs, and it's a subject quite close to my heart because I feel every good developer should document their APIs. I know it's not everybody's favourite topic, and you might think it's unnecessary because your schema is so well defined that it's obvious what it's doing, but I can guarantee you people coming to it for the first time, it may not be as obvious to them. So it's a really good practice to get into describing what your objects represent and what the fields within those objects, what they actually represent as well, because it might not be as obvious as you think, so it's definitely worth doing. So let's just take a quick look at GraphQL Voyager again, and you can see that any tool that ingests a GraphQL schema will take with it the documentation as well, and it will usually display it back to you. So Insomnia will do that, GraphQL Voyager will do it, Banana Cake Pop will do it. So really nice, it's all built in. It's one of the really powerful features of it, so there's no reason not to do it really. So yeah, looking at GraphQL Voyager and selecting our command object, there's no description about what it is, then there's no description about what the fields are. Same with the platform. And for example, what is a platform? What does that represent? Does it represent all platforms within an organization? Does it just represent platforms that have a command line interface? So again, when you actually start looking at it, it's maybe not as obvious as you think, and you should probably describe what these things are doing. So in order to do that, we'll move back to our application, and we'll just stop it from running, and we'll go into our models folder. And for the moment, we are going to specify our documentation directly on our model classes. So let's select a platform class, and you just decorate the class with GraphQL description, and then whatever you want to put in here. So represents any software or service that has a command line interface. So this is useful. So it means that somebody using this API, they're not going to expect to see platforms in here that don't have a command line. Okay, so straight away it's useful. Now you can see it's complaining, so we do need to bring in the namespace for hot chocolate, and basically we just repeat this for our attributes as well. So I'm just going to do one for license key. You decorate the property with GraphQL description, and we'll give it some description. We'll say represents a purchased license for the platform. Okay, or represents a purchased valid. So again, useful. It's not just a historical license key that we've had and it might be invalid. We know that if we're querying this, that it's a valid license key. So again, documentation is definitely useful. Let's save that off and let's run that up. And we'll refresh our schema in Voyager and we'll see what we get. So you can see here straight away our platform object now has a description as we have specified, and if we click on our platform object, you can see that our license key now has a description as well. So it's really, really easy to add documentation, and I highly recommend you do it. In the next section, we're going to revisit documentation, sort of, and we're going to look as well actually at the license key attribute, and we're going to have a bit of a discussion around whether we've structured our API in the best way. So we'll do that in the next section. All right, so in the last section, we added some documentation to our GraphQL API, which is of course a good thing, but just coming back over to our application and looking at how we did that, what we did was we went to one of our models, our platform model in this case, and we started annotating our class and the properties in the class with this attribute here, this GraphQL description attribute. Now you might go, well, that all sounds perfectly reasonable, but one reservation I have in my mind is that really for me, both our command and our platform models aren't really technically anything directly to do with GraphQL. Yes, in this instance, GraphQL is making use of them, of course, but they're not really part of GraphQL. I mean, and I said at the start of the video, you know, this particular part of the setup is a totally agnostic part of the setup, and it's almost slightly separate to GraphQL. And taking it a step further, if we were building a larger application, it's entirely conceivable that the GraphQL part is just a part of it, and these models are actually being shared by other services within our application. So it could be entirely possible that we could have a bigger application that uses REST and makes use of these models and also makes use of GraphQL. And they too use these models, and there might be other things that use these models. So the question in my mind is, do we really want to be, and I'll use this word sparingly, do we really want to pollute our internal models that are really nothing to do with GraphQL? Do we really want to introduce GraphQL specific stuff into them? Does it make sense? Now, in the case of documentation, you may say that's relatively benign and it doesn't really matter, but for me, I don't really feel too comfortable with it, and I personally would like to find a way to divorce or separate out, still have documentation of course, but not have the documentation in our models, because for me the models are a separate kind of thing, and I'd like to keep them a bit more pure and a bit more divorced or agnostic from the GraphQL specific stuff. Now, just taking that a little bit further, and I actually think this is a more important point, what a model is, in my mind, is it's an internal representation of the data that we want to store. When I say internal, I mean internal to the application, and even from a business perspective, internal to the organization. So looking at our license key property, which is the reason I actually introduced it in the first place, it's entirely reasonable and conceivable that you would want to store your license keys with your platform model. That's perfectly reasonable. But then, would you want to expose that property externally via an API? Maybe you would, maybe you wouldn't. But the point is, I wouldn't want to directly expose our models by default out to a public-facing API, or even an internal API. I wouldn't want to do that. So again, I'm looking to find a way to kind of separate out some of our concerns and leave our models purely as internal representation of our data, and find some other way to build kind of the GraphQL layer up on top, and, you know, yes, deal with our documentation, but also pick and choose what properties we actually want to expose out. So that's really where I'm going with this conversation. I think it's an important conversation, and the way we will continue to build our API in this tutorial is by taking a slightly different approach. So that moves us quite nicely on to a bit of a slide deck. So it's just one slide, so we don't need to get too bothered about it. But I want to talk about two approaches that are defined within the hot chocolate framework, or the hot chocolate guys define these two approaches. In fact, I think there's three approaches, but I'm just going to focus on these. So I want to talk about annotation versus code first approaches. Now, the annotation approach, they actually refer to it as the pure code first approach, and that's what we have been using so far. And what that basically means, we're using .NET code, pure .NET types, and we are annotating them, those types, those classes, with attributes to provide GraphQL features, which is exactly what you've seen. We've decorated our model classes with certain things to provide certain features, and we're directly exposing all those properties out via the API. So that's what we've been doing first, that's what we've been doing so far, and that's the annotation or pure code first approach. Now, that might be appropriate for your use case. However, they define a second approach, which is code first, which I think is a bit confusing, pure code first and code first. That's why I've opted to use the annotation language. I think it makes the distinction a bit clearer. And what the code first approach is, we start to introduce dedicated GraphQL schema types, and you'll remember from the introduction in the video we talked a bit about types. And what that allows us to do is separate or abstract out concerns, which is exactly what I'm talking about. Now, you can actually mix both approaches, so you can have a bit of both, and, you know, depending on what you're trying to do, that's possibly appropriate. In a long way, I've described that we are going to move to a code first approach and start introducing types to deal with the concerns that I've raised. And if we just come back to our architecture, let's do a bit of an architecture check. We'll just show you how that overlays on our architecture. We've done all this stuff, you should be familiar with it. We've done this stuff, we've got a query or two queries set up via a root query type. And this is what we have so far, but what we're going to introduce now is a type. And types are basically, if you look the way I kind of think about it, they're almost mapped to models, and they provide this kind of GraphQL specific layer of abstraction. So we are going to move on now and create some types. All right, so in this section we are going to actually introduce types to our application, and it'll probably become a bit clearer. The word type is a bit confusing actually, because it's used in a lot of different contexts, and it can get a bit confusing, but I think actually stepping through this example it will become a bit clearer. So one of the things I want to do, just in terms of organization, we have our GraphQL folder, but I'm going to now create some subfolders in the GraphQL folder that relate to both commands and platforms, because, well, you'll see this as we start building out our examples. We're going to create a platform type, we'll create a command type, and when we come on to working with mutations, which is, you know, changing data within our, changing data using our API, we're going to introduce a couple of other classes related just to our command and our platform. And so I feel it's nicer to have those kind of segregated in their own area. So it's really just an organizational thing from my perspective. So we're going to be creating a platform type first. So in GraphQL, new folder, and the folder will be called platforms. Great, and then we are going to create a type within our platforms folder. So new file, and we just call that platform type.cs. So namespace as usual. And it's Commander GQL, and we're in GraphQL, and we're now in platforms. Platforms is one of those words I always tend to spell wrong, just checking that it's correct. And then it's just a public class called platform type, but it inherits from something called object type, where we tell object type what type we want to kind of build upon, basically. And we want to build upon our platform model. And we'll just singularize that. So let me just correct up these kind of errors. So object type actually comes from this namespace, hot chocolate types. And then our platform comes from our models area. So just to go over this again, we're creating a platform type class, and we're inheriting from object type, which comes from hot chocolate types, and we're telling it that we're basically using our platform model as a basis on which to build. And then what we do and what we configure within this class is the things that we want to kind of layer on top of our platform and provide by way of specific GraphQL functionality. So it means we can then remove any GraphQL specific stuff from our platform model and leave it in a cleaner state. And it also gives us more control over how we want things to behave. Well, I think it does anyway. But one thing you will notice is that the previous approach, the annotation-based approach, it did a lot of heavy lifting for us. We actually have to do a bit more work taking this code-first approach. And so depending on your personal preference, it may be a good thing or a bad thing. But I feel this is a better approach in the long run for the kind of use cases I encounter anyway. So what we need to actually do is override a configure method that is provided by our object type base class. So protected override void, and it's the configure method, and it's kind of pre-populated some stuff for us. But basically we want to make use of this descriptor parameter, and that's basically what we hook into to kind of configure our platform type class. So why don't we put some documentation in at the class level? So we use the descriptor, and it's quite simple. We just use this description method, and then we just paste in whatever the description is. So what I'm going to do is actually come back over to platform, and I'm going to copy this out just to save me typing. And I'm going to paste that in here. So it's the same. But then what I'm also going to do is I'm going to take this out from here. Okay, and I'm also going to delete this, because basically what we're going to do is we're going to not expose this property through GraphQL, so it doesn't need a description, a GraphQL description. So save that off. So basically, this is restoring our platform class back to its pure form, basically. So we don't need to touch that again. And we just do everything within here now. So basically, this is now adding a descriptor to our platform object. Now, if you want to ignore the license field, again, descriptor, and then you just basically hook into a field, and we'll use a lambda expression to specify what field it is we want to work with. And in this case, it's license key. And then we simply specify that we want to ignore it. Okay, so that's basically saying, well, it's quite straightforward what we're doing there. We want to ignore it. Now, the one other thing that we do need to actually introduce is something called the resolver, and I did mention these at the start. Now, what the resolver is actually going to do, it's basically telling our platform type how it's going to get, in this instance, our commands that are associated to the platform. And again, you know, the previous approach, all that heavy lifting was kind of done for us. We just had to use the projection stuff to allow that to work. Here we have to do a bit more heavy lifting. So the way we do that is within our platform type class, we're actually going to specify a subclass, which is private, so private class. We'll call it resolvers. And it's in here we tell it how to resolve, well, whatever we want to resolve. So public, iQueryable, need to bring in that namespace of command. I think I've spelled this wrong, query, yes. Queryable command, and we'll call it get commands, and I'm going to bring in this namespace using link. And then we're going to specify platform, scoped service. And this should look quite familiar actually. It's almost similar to the query that we've previously used. App DbContext, context. Let me just bring in these things here. So we'll bring in scope service, which is coming from hot chocolate, and we'll bring in the app DbContext, which is coming from our internal namespace. And then all we do is return DbContext commands, which is the data set, and then we specify a bit of a where clause. And this is just basically using the foreign key to make sure that we only bring back commands that relate to this platform. So P platform ID is the equivalent to platform ID. Now that probably doesn't make, well, it should make some sense to you hopefully, but make sure I take that right. But it will make more sense because we actually have to make use of this resolver from within our configure method. And so we pass over some of the parameters that are required here in order to pull back the relevant commands. So last thing we need to do is do a descriptor, use descriptor. And this time we want to I'm going to take a new line because there's a few commands we're going to chain here. So field, using the lambda, we'll go to P commands. And then we use resolve with, and we specify this. And then we just need to pass in some stuff using a lambda. So P goes to P get commands, default, and default. Not quite done, so then use DbContext, app DbContext, and again this looks quite similar to how we've called our queries previously, and then I'm going to give it a description as well, just while we're at it. And I don't know, this is the list of available commands for this platform. It's probably a bit of an obvious one, but we'll do it nonetheless. We just finish that off. Cool, so let's save that off. And the other thing we need to do is come over to our startup class, and this is the step I always forget to do. And in here, we need to add that type. And we do that saying add type platform type. And then we'll just need to bring in that namespace. There we go. And that should be okay, that should be us finished, I think. So everything's saved. I think all we need to do now is do a .NET run. And see how we go. Okay, so that's a good sign. It's all up and running. Let's come over to GraphQL Voyager, and we'll just take a look at the schema. It shouldn't really look any different, to be honest. Well, yeah, it will look slightly different. Yes, it will look different because we've removed our license key attributes, and we've added a description to our commands array. So let's go to Voyager. So if all things have worked correctly, we still have a description on our platform, which is something we added. On our platform, you can see we just have ID and name. We no longer have a license key, which is good. And if we drill in here, you can actually see that this was the description we added to this commands array, the list of available commands for this platform. And there you go. I spelt platform wrong. Let me just fix that up. It's not the most critical thing, but it will annoy me. Okay. I'm not going to bother restarting it, but what I am interested in is just making sure that our existing queries continue to work. So we're going to use our query here. Let's do a schema refresh. And this should just work as it did before. There should be no difference. There we go. And indeed it does. So that's all cool. So we've added a type in. We've used the resolver to basically tell it how we need to resolve our list of commands. And other than that, it all looks pretty much the same, apart from the fact we've taken out some fields. And in that way, we've cleaned up our platform class, our platform model, internal model. So it's a really good step forward. So what I want to do next is add a type for our commands. And then we're almost ready to move on to a few other things around querying, such as sorting and filtering. And then we'll be moving on to further parts where we talk about mutations and subscriptions, but that's all coming a bit later. Okay, so in this section, we're going to add another type, this time for our command. So we've created one for our platform. We're going to introduce the same concept for our command, just to keep things a bit more consistent and just to embed how we do that. So I'm going to kill my server running, and back over in our GraphQL folder, I'm going to right click and create a new folder for our commands. And in there, I'm going to create a new file, and we're going to call that command type.cs. And then, as usual, namespace, GraphQL, commander, GQL, we're in GraphQL, and we are in commands. Cool. And then it's just a public class called command type, and we inherit from object type. We specify the type, which is going to be command this time. Cool. So let's just bring in the namespace for this, which is hot chocolate types. And then we're going to bring in command, which is an internal namespace. And then just as before, we're going to override the configure method. So protected, override, void, configure, tab to complete that out. Take this out, and we'll make use of this descriptor. And the first thing we'll do is we'll add a description for the class itself, the command class itself, and we'll just say, I don't know, represents any executable command. Probably a bit obvious, but we'll put it in. We've been going on about documentation, so be remiss of me not to put it in. Now, one of the things you will notice, I think I've said this already, is that you do need to do a bit more heavy lifting, of course, with this approach. So again, we need to provide a resolver, that will basically resolve the platform that this command belongs to. So we're working with commands, we're querying potentially with commands, and we need to go and fetch the platform that it relates to. So it's basically what we've done with the platform type. We're just kind of flipping it around. So private class, we'll call it resolver. Resolver's plural. And then we'll just define a method. Public returns a platform, single platform, and we'll call it get platform. And we're going to get passed in a command. We'll call that command. And we're then requiring a DbContext, which is a scoped service of type at DbContext, and we'll call that context. Okay, so exactly the same kind of pattern we've used before. Let's bring in the namespaces using hot chocolate and our data namespace. So we have our DbContext, and then we simply just return context and platforms this time, and we're going to use link expression first or default, and then we simply say we just fetch the platform that we need. So P goes to P, and we will retrieve. We need to bring this in first before this will work. So we'll control period to bring in link. So P goes to ID. That's the platform ID. Goes to the command platform ID, the foreign key. So that's bringing us back the command that. Bring us back the platform that the command relates to. Okay, can get a bit confusing when you're going both ways. So, all right, so then all we need to do is make use of this resolver, and we'll use the descriptor again. I'll take a new line because there's a few things we want to chain here. So the field is going to be C goes to, C platform. And then we're going to resolve with resolvers, as we've done before. And then we're just going to specify, again using lambda, we want to use get platform, and then we're going to just pass in default values. Cool. And then we want to use DbContext, and it's just of type app. DbContext. Don't forget the round brackets, and then we'll put some description in as well. And this is relating to the platform. So this is the platform to which the command belongs. It's probably a bit of a circular reference, but nonetheless, we'll leave it there for just now. All right, cool. So let's do a .NET build. That's all good. And let's do a .NET run to run it up. Now our schema shouldn't have changed much, but let's just interrogate that using Voyager. Should be pretty much the same. Well, it will have changed. We'll have added descriptions in, so let's just check that. So we've just done our command. And there's no description there. That's interesting. I know what I've done wrong. So this is a good example, perfect example of remembering, must remember to add the type to the schema. Didn't do that. So I knew I'd do it at some point in the video, and there we go, I've done it already. So command type. Well, that's a good example of what happens if you don't do that. We'll bring in the right namespace, which is this one here. Cool. All right, so let's try that again. Let's just run it up. And let's rerun this, or refresh this. Okay, and click on command, and yes, represents any executable command, and we've got some description for our platform attributes. So that's cool, that's all looking nice. So let's come back over to Insomnia, and let's rerun our platforms query, which was working before, so there's no reason why it shouldn't be working now, so that's still working okay. But what we really want to test is this one here, so let's run that. Okay, so we are getting back our commands, but we're not getting our platform. Let's see what we've done wrong. Let's come back over here. I'm going to stop this for a moment. I don't think there's anything wrong here. Let's come back to I think I might know what the problem is. So if you come back to our query, so interestingly, we don't actually update our query. I should have mentioned that when we did the platform type. But one thing we can take out is this use of projection, because we have explicitly provided resolvers. So you'll remember we had to use projection because we had to basically tell, when we were using a attribute approach and annotation approach, we had to tell it project forward and walk the graph to get the child classes. We don't need to do that because in our types we have explicitly said. Thinking maybe that's why we've had an issue. So let's test that theory. I'm going to take that out from here because we're not using it anywhere now. So let's save that. Let's save our query. So again, I took out the attribute where we use projections, and let's run that again. I think that's probably what the issue is, probably getting confused. So let's run this again. Yes, there we go. That's okay, that's what we wanted. Yeah, so cool. So it's now using the resolver to pull back our platform. And let's just run this just to make sure it's not broken. It's fine. Cool. All right, so a little interesting tidbit there. When you're using types and resolvers, you probably need to take out the relevant use projections attribute decoration. So that's it for types now. We've got a type for a command, we've got a type for our platform. What I want to finish off this kind of querying section on, it's not more of a section, it's a large part. I want to talk about filtering and sorting and how you can actually add that in really quickly and really easily to your query components of your GraphQL API to achieve, well, sorting and filtering. So let's do that next. All right, so in this section I did promise we would talk about filtering and sorting, and we're going to do more than talk about it, we're going to implement it, but it's actually super simple using the Hot Chocolate framework. You don't really need to do that much coding at all. So I'll show you how to add it, and then we'll run some queries to show you how that works. So quite a short section, not too code heavy, yeah, fairly straightforward. So this is one of the reasons I do like Hot Chocolate. It provides this stuff out the box, but you do have to opt into it. It's not there by default, which is nothing wrong with that. I quite like that approach. You've got to opt into the stuff that you want. So how you add filtering and sorting, not surprisingly, you add it into your query object here, or your query class, should I say. And all you have to do actually is decorate the methods, the query methods, that you want to have filtering and sorting on it. So you just use filtering, and you just use sorting. It's basically that simple. So we'll just copy these, so this, and we'll paste this in here. And of course, do not forget that we actually need to add it in here as well. So after our types, we will just add filtering and add sorting. So again, two places you got to do it, allowing our schema to deal with that, and that's really it. So we'll save that off, do a .NET build, but I would be very surprised if we had any issues. And they'll do a .NET run. There you go. So this section will actually spend a bit more time, not in the code, but actually writing some queries. So we're going to write a filter query now, and filtering, is basically just reducing down your result set to filter on, well, something like an ID or something like that. So let's do a new query, new request, and we'll call this filter query. And this is where, I'm not going to go into too much about writing GraphQL statements. That's kind of a separate topic area. It's a large topic area, and I'll put some links to some good documentation that you can take a look at. But we want to exercise our changes, so I will take you through that, of course. So again, a post request, GraphQL query, create that. And we'll do sorting, we'll do filtering. Yeah, let's do filtering first. I think we said we'd do that. So let's come back over here, copy this in to filter query. I'll place that in here, do a schema refresh, it should be okay. Cool. And we'll do it super simple actually. Query, and let's look at our commands query. And what we'll say, this is where it's slightly different to what you'll have seen before. You can now see we have access to where and order, which is basically filtering and, well, ordering. Filtering, we'll do where, and then you just specify what filters you want. So open curly brackets and we can, say platform ID. So again, we're querying our commands, but we want to just pull back those for a specific platform. So platform ID, and then we'll just say is equal, and you get all these different operators here. We do that again, so you can see all the different operators. And again, I'm not going to go into that here, but EQ is equal, and we'll specify 1. So I think the platform ID 1 was .NET. So this will bring back just our .NET stuff. Now you can see it's complaining because it's saying you must have a selection of subfields. So that's our query, but we need to bring back, do we want to bring back the ID? Do we want to bring back the platform? Which we do, and bring back the command line, and bring back the how-to. Now you'll see platform is, complaining because platform is an object. So we need to define that further, and that's why we use the curly brackets to go into that particular object type. Okay, so let's just reiterate. So query, we're using our existing command query, making use of the where keyword. We're specifying some parameters, in this case, the platform ID, and we're wanting it to be equal to 1. And then we're just specifying the fields that we want to come back. There we go. So cool, we just get back our 2 commands with the the platform ID equal to 1. And we're not displaying them. Actually, let's do that just for clarity. It's just called ID, isn't it, in that case? ID, so ID here should be 1. There we go. So ID is 1, ID is 1. And that's what we were filtering on. So you can see how powerful that is and how much you can extend that. And then we'll just do the sorting query. So new request, sorting query. Again, we're getting used to this now. Post request, GraphQL body, create. And we'll just copy in the URL, copy, sorting query, cool. And let's use our platforms this time. Let's do a platforms query just to show you that it's working on both. So query as usual, platforms query, get schema. That should resolve now. Just want to make sure that's working. Yeah, that's better, platform. And then we'll say order. And we will pass in name. And then we'll just specify how we want that to be ordered, ascending or descending, so alphabetically descending. Again, we'll get this complaint here saying that we haven't specified some subfields, so we'll just bring back the name, I think, in this instance. Run it, and you can see here, let's put it in alphabetical order. If we change that around, ASC, should flip it around. There you go. So filtering, sorting, very easy to add. I'll leave it to you to kind of experiment with the GraphQL query language to make use of it and work with it. But again, very powerful, very easy to work with. So with that, that kind of concludes our section on querying, which was a big section. And now we're going to move on to looking at mutations, which is changing data. And then after that, we're going to look at subscriptions, which is getting real-time data notifications out of GraphQL. So we've actually covered most of what we need to cover. The next sections are going to go pretty quick because we've covered most of the groundwork, but let's move on to that next. All right, so in this section, we're going to move on to mutations. And as I've previously mentioned, mutations are when you want to create data or update or delete data. So changing data or mutating data, which is a fancy way of putting it. So before we move on to writing some code, let's just do a bit of an architecture review. So this should all be very familiar now. We have added GraphQL to our request pipeline, not quite added WebSockets yet, and that's for the subscriptions section. Got our models, got our data access, our DbContext class, SQL Server's in place. We've finished our queries. We've done all this stuff. We introduced types to abstract away GraphQL specific stuff from our models. And yeah, this is where we're at basically. So what we're going to do next is add a mutation to a mutation class to our schema, and we're going to then add individual mutations for adding a platform and adding a command. And as part of that, we are going to expect some inputs. So we're going to have an input class for each one of those mutations and a payload, which is basically the result set. So input and output, or as it's named here, payload, which is the kind of language used within GraphQL. So all will become a bit clearer later as we, well, become very clear in momentarily, because we're going to move over to the code now. So back over in our application, I'm just going to kill running server. I'm going to clear that, and I'm going to clear this down. So the first thing we want to do is over in our GraphQL folder, I want to add a new root mutation type. So mutation.cs, and as usual, namespace, and it's Commander GQL GraphQL, and it's just a public class called Mutation. All right, and as I said, we're going to create two methods in here, one for adding platforms and one for adding commands. So the first one we're going to do is platform, so it's a public, and it's going to be a synchronous method call this time, so we use the async keyword, and of course it's going to return a task of type. Now we don't have this type yet, but again, coming back here, it's going to return a task of type payload, or add platform payload. So let's give it that name now, add platform payload, and we'll create these in a minute. We'll create this in a minute, and as well as the input class that we require. The name of the mutation is just add platform async, and as inputs, we're going to require an add platform input, which again does not yet exist, and we'll just call that input. And I'm going to take a new line, and we're going to expect a scoped service, which is our DbContext basically, our app DbContext, and we'll just call that context. Okay, and I think I spelled that wrong, context, there we go. Scope service app. Okay, so we've got quite a few errors going on here because we need to bring in quite a few namespaces. So let's bring in task first. So threading tasks. We don't have either of these yet, so they'll remain errors for the moment. So we'll bring in scoped service from Hot Chocolate, and we'll bring in app DbContext. There we go. Now, the other thing we need to do before I forget it is we need to decorate our method with the use DbContext attribute. So use DbContext, type of, and then it's just app DbContext. So again, that's just to make use of our multi-threaded DbContext. So bring in Hot Chocolate data as well. All right, cool. So before we fill out the actual insides of our method, which is actually pretty simple, I'm going to create these two classes. Now, actually, technically, they're not really classes. They are, well, they could be classes, but we're going to use a new type within C#9, which is the record type. And actually, just while I'm remembering, I should have some documentation on that here. And it just basically simplifies the use of, I suppose, instead of using classes, you can use this record type when you want to use value-based equality. So it says here in C#9, we introduce records. It's a new reference type. You can use, instead of classes or structs, records are distinct, and that record types use value-based equality. So two variables of a record type are equal if the record type definitions are identical, so on and so forth. So I'm not going to labour that, but I'm just mentioning it because you may not have seen the use of record before, and it's just something new with C#9 or .NET 5, however you want to look at it. So we could write them as classes. It would just be a bit more long-winded. The record, using a record, it's a lot quicker and a bit more elegant. So the first thing we're going to write is our add platform, and I can see a spelling error already. Add platform input record, and then we'll add our add platform payload. So I'm going to add that in the actual platforms folder. And again, this is why I've created these folders, just to keep this kind of collateral separate. Otherwise it could get a bit messy. So add platform input.cs, add platform. Again, I always spell this wrong. Platform input. Okay, cool. And then over here, it's just namespace as usual, and we are in Commander GQL, we are in GraphQL, and we're in platforms. And it is literally one line of code. So it's just a public record, add platform input, And all we're expecting as an input is a string of name. That's it. That's simple. And just to remind you, when we're creating a platform, we don't provide the ID, obviously, because that's created for us. And within our GraphQL environment, we're not wanting license key. And we could potentially pass in a list of, or a collection of commands at the point where we create a platform. That's feasible. We're not going to do that here. We're going to keep it simple. So we're just going to create a platform with a name. So back over to our platform, add platform input record. Yep, that's all we need to do. So remember to save that. And then we're going to add something very similar, but this time for the payload. So again, we are expecting a add platform payload as an output. Let's just bring this namespace in. So it's found that. So that should resolve down. Cool. So we just need to do this one now. So back in platforms folder, right click, new file, add platform payload.cs. And we're going to use a record as well. But before we do that, just namespace, command or GQL, GraphQL platforms, and its record, or public record, add platform payload, and we're just expecting to return a platform. We'll call it platform. Cool. And we just need to bring that namespace in, and that should resolve down. So we'll save that off now, and we'll come back over to our mutation. Fantastic. So inside our actual mutation, where we do the work effectively, it's not really that complex, to be really honest with you. First thing we're going to do is just create a placeholder platform. So we'll just call it, say, var platform equals new, not Newtonsoft, equals new platform, and we'll just give some values. I'm going to bring this namespace in so we get use of the IntelliSense, and the only thing we are going to populate is the name, and we're going to make that equal to input name. We don't actually need the semicolon, and we need that there. All right, so we're just creating a new platform that we're going to then pass over to our DbContext. We're going to go to our platforms data set. We're going to add the platform to it. Now at this point, we've just added our newly created platform object with the input that we've been given to our DbContext. It's not been saved down to the database. So in order to do that, we need to say save changes. So we're going to use an asynchronous save change method. So await context save changes async. Fantastic. And we're not quite finished because we do need to return the payload. So return new add platform payload, and we're just going to return the platform. And that should be us done. Okay, so let's do a .NET build. No, it's not us done. There you go. I keep forgetting we've got to come over to startup, and we've got to add our mutation type. So add mutation type, and it's the mutation class. Where is it? Here, add mutation. Okay, and that should resolve because it's in the same space as query. So that all looks good. So let's save that. Let's do a .NET build. And hopefully, we get 2 errors. So let's have a look. We've done something wrong here. I'll put the semicolon in. Let's try that again. Okay, we're all good. Okay, so that's the coding done. So in the next section, we're going to test our mutation to see if it works. So fingers crossed. All right, so in this section, we are going to test that our mutation actually works to add platforms, well, ultimately to the back end. So let's do a .NET run, not rub. I wonder what would happen if we type that. Okay, so .NET run, and our API is up and running, that's cool. If we come over to Voyager, we'll do a quick refresh to pull down the new schema. Now what you can see here, don't panic. It basically will display a query view, and now you can see here we have a mutation view. So we click on that, you can see, yes, we have a mutation now with our add platform, well, mutation in it. And if you click on that, it basically takes you over to what it is. that we have an input and we have an add platform payload as an output. If you click on this little arrow, it will tell you what the input is, and then it will even expand it. Now you can see here that we probably should be putting in descriptions and documentation here, which I would leave that to you to do as a bit of homework, but it's definitely something you should be putting in here. I'm not going to do that just here, just to move things along. So yeah, we have a mutation, it returns an add platform payload type that is basically just maps through to platform objects. So that all looks good. Let's come back over to Insomnia then and test this out. So what we're going to do first of all, these are all queries. So I'm just going to create a new folder. I'm going to call these queries. And this is just a bit of tidy up, to be honest with you. You don't need to do this if you're not really too bothered. I'm just going to do it just to keep things nice and tidy. All right, it's probably a quicker way of doing that, but okay, let's minimize that. Okay, just click on it, and then new folder, and we've got all these mutations. All right, fantastic. So right click, new request, and we'll call this add platform. Now again, I'm just going to label this point. We've been making post requests even for our queries. No different here. It's just a post request with a GraphQL body. So just again, just to kind of label the point with REST APIs, if you're used to using REST, typically you'll use get to read data, you'll use post to create data, put in patch to update, and delete to delete, obviously. GraphQL is different. As far as I'm concerned, everything is just a post request, and whether it's a creation or a reading is basically done within the query body that we pass as part of the GraphQL body text, really. So let's just create that, just thought I'd make that point. We need to pull in an endpoint. And again, the other point, which is probably quite obvious, is it's just the same endpoint. There's no different endpoints depending on whether you're reading, writing, creating, or using commands or platforms. It's all just the same endpoint, which again, I personally quite like. Okay, so we'll just refresh that. We've brought the schema down. Fantastic. And unlike queries, instead of writing query, any guesses what we write? We write mutation, curly brackets, and we have our add platform mutation. And then to provide input, it's rounded brackets, not curly brackets. Tab to provide input, colon, and then we can provide inside some curly brackets a list of attributes that will be accepted. And we only have one in this case, which is name, colon, and then we just provide the string for that. So let's say Ubuntu. Whenever I'm using Linux, that's the variant of Linux that I use. And you can see here it's complaining because it does expect us to pull back some fields. So bring back a platform object, and then we're going to bring back our ID, and we're going to bring back the name. So that should be good. So again, mutation, the name of the mutation, input in rounded brackets, make sure you're the rounded brackets, and then you just provide the attributes within our curly brackets, and it's just a name value pair. So again, this video is not really about GraphQL language. It's a huge subject area, so I'm just kind of scraping the surface to kind of test our API. So let's send that over now. Okay, cool. So that looks kind of successful. So we brought back our data payload with an ID of 5, which kind of makes sense, and the name Ubuntu. Fantastic. So let's just come over into our database, although I'm fairly confident that it's being created, but let's just do a new query. Let's make sure we have the right database selected, so it's commands DB, and then we'll just do select everything on platforms. And bring that back. And there we go, we've got Ubuntu in there with no license key, which is great. And we can even check that by coming back to our queries and going, let's get all platforms, so send over. There we go, and we have our payload returned, so that's cool. So mutation, creating data, working. So the next one we're going to do is a creation of our commands, and then we're going to move on to looking at subscriptions. All right, so in this section, we're just going to add a second mutation to allow us to add commands to our, well, ultimately to our database. So it's a very similar pattern, not similar, it's the same pattern that we've used already for platforms. So yeah, let's just jump over to the coding and get started. Now, the first thing that was bothering me actually was when I created this mutation file. I know it's silly and it makes no difference. I just don't like the fact I had a small m, so I'm going to capitalize the m. The class itself is correct. That was just bothering me. Now, before we come on and create a very similar method for adding a command, I'm going to first of all create the inputs and the payload for our command ahead of time. So yeah, we're going to do that within the commands folder. So first thing we'll do is the input type. So new file, add command input.cs. So you know what this is now. Obviously, it allows us to add stuff to our mutation. So namespace is command.gql, GraphQL, and we are in commands. Fantastic. And again, it's just a public record called add command input. And this time it's going to expect a few inputs, so how to, string of command line, and an integer for platform ID. Okay. Now you can name these anything you like, but I'm just kind of keeping them in line with what exists within our model. You don't have to though, obviously, because we'll take care of that a bit later. So just semicolon to close that out. So that's all we need to do for our add command input. Save that off. I'm going to do a quick .NET build just to make sure that's all okay. And we have a warning in startup. Don't know why that's complaining. Yeah, it's weird, isn't it? Shouldn't be complaining because that's all looking okay. Okay, strange. Anyway, let's keep going and see if that resolves itself. Not sure why that's doing that. Sometimes Visual Studio can kind of get itself, Visual Studio Code, should I say, can get itself in a bit of a pickle. So we'll add the mutation next. So commands, new file, add commands, payload, .cs. And just a namespace of command.gql, GraphQL commands. And again, it's a public record called add command payload, and we're just going to expect it to return a platform. Oh, not platform, sorry. There you go. A command called command. And just get rid of that. And yeah, auto-corrected command. There we go. Let's bring in the namespace. Cool. All right, and then just finish that off. Looks good. So that's all done. .NET build. Getting 0 errors, that's good. And then we'll come back over to our mutation. And yes, now we're going to add a second method, our add command async method, that will allow us to make use of those records to create command. So new line, I'm going to put in the decoration first, so use DbContext, type of app DbContext, and then the method itself will look very, very similar. Public async, returning a task of type add command payload, and we're going to call the method add command async, and it's going to request as an input and add command input. Just call that input, new line, and scope service, add DbContext, and we'll call that context. Cool. And then to be honest with you, it's really not any different from this. It's exactly the same pattern. It's just that our command object is slightly more complex. So we'll create a temporary holding object. We'll just call it command, and that equals a new command. And we will say how to equals input how to, and I'll say command line equals input command line, and don't forget the comma. And then finally, platform ID equals input. Platform ID. And don't forget the semicolon here. Cool. And then in the same way, we'll just say context, commands, add command. Doing await on our context. Save changes async. And then we'll just return new add command payload, and we'll pass back the command. Fantastic. Let's do a .NET build on that. Yeah, this is interesting. I think there's maybe something wrong with the way it's looking for references, because we didn't bring in the add command payload or add command input, and it's not giving us the errors that we would expect. And so even when I put my cursor in here and click period, it's not giving me any resolutions, but the compiler is finding that we don't have the namespace. So what I'm going to do, and I've seen this before, I'm just going to kill this, make sure everything's saved. I'm going to reopen it and see if that resolves the issue. I find sometimes this can happen. And hopefully this will error out once it finds its way, I'd like to think. If not, we'll just bring in the namespace. There we go. So it's actually found that, found that we've not got the relevant namespace in. And it's picked up that this is wrong, which is good. So it's actually at DbContext, not add. That's better. So yeah, I find that happens occasionally. It can just get itself a little bit confused. And I think if you noticed there was an error in startup, or it thought there wasn't one down there. So that's good. That's put my mind at rest. So that's all good. So let's do a .NET build again and we should be okay. And indeed we are. Okay, cool. So that's the coding done. And just to sort of say, we don't need to do anything else in startup because we've already added the mutation class, which contains our new mutation. So that's it for our code. So in the next section, we'll just test this before we move on to subscriptions. All right, so let's test our command mutation. So do a .NET run to run it up. And as usual, we'll use Voyager to see what it thinks is going on. So again, don't worry, it kind of resets to the query view. Just come back down to mutations. We should see we have 2 mutations and it's all looking pretty good. So back over in Insomnia, we're going to add a new mutation request. So new request, we'll say add command, post request, GraphQL, create, copy in the URL, and paste that in here. Schema refresh, cool. So we're going to write another mutation, so mutation, and we should have 2 now, indeed we do, add command, similar thing, rounded brackets, we're expecting an input, colon, curly brackets. I'm going to take a new line, although I'll probably pop in one of our inputs, so yep, it's asking us for how to, which is fair enough, so how to, colon, and then, oh, I don't know, how about perform directory listing. Keep it super simple, and the command line is ls, and the platform ID is Ubuntu, so 5. So not the most elaborate of command lines, but it's only one I could think of in the spur of the moment. So command, this is us just bringing back the object that gets created. So how to, command line. And I'll tell you what we'll do is we'll bring back the platform as well. And we'll just select the name. So that should, because we've given it an ID of 5, it should pull back the fact that that's Ubuntu Linux. So let's send. There we go. So again, we have a new command in our DB with an ID of 5. It's pulled it all back, and then it's pulled back that it's Ubuntu. So quite nice. And again, you can start to see the power of GraphQL. It's very nice. We could take our mutations further and you can start adding nested objects from within the mutation. So a good example would be, yeah, creating a platform, but at the same time creating maybe 1, 2, or however many commands along with it. You can absolutely do that. Not going to show it here, just going to take too much time. Maybe it's something you can look at doing yourself. So yeah, that's it. That's us covering mutations. You'll notice I've not used delete or update. I think using this pattern, you can probably figure that out yourself. All you're really going to probably change is in the mutation itself, what you're actually doing from a database perspective. Are you adding a record? Are you updating it? Or are you deleting it? But the input and payload construct actually remains exactly the same. So I think you should be able to figure that out pretty much yourself. Fantastic. So the last part of this tutorial is coming to take a very quick look at subscriptions and how they work. And then we'll do a bit of a wrap up and we're done. All right, so in this section, we are going to be moving on to subscriptions. And I like to think of subscriptions as the third leg of the milking stool when it comes to GraphQL. So we have queries, mutations, and then thirdly, we have subscriptions. So that's what we're going to be looking at now. So let's do a quick architecture check just to see where we are and put things in context. So our request pipeline, we have added GraphQL to it. For subscriptions, we are going to need to add WebSockets, which is what subscriptions use. And I'll talk a bit about what WebSockets are when we come to that point. The rest of the stuff I'm going to kind of skip through, as I've gone through it many times this video. So we're basically at this point in time. So what we're going to add now is a subscription. And subscriptions rely on WebSockets. So before we talk about what WebSockets are, let's just talk a little bit about subscriptions and what they are and why you would use them. So basically the use case is, let's think of an e-commerce application where we have our GraphQL API that allows us to create orders, okay, in an e-commerce type environment. So an order is created, you might have other services that want to be notified when an order is created, such as maybe a dispatching service or a warehouse management service or something like that. So in that case, the warehouse management service would subscribe to our subscription endpoint for added orders or when orders are created. And so when an order is created, the endpoint that's subscribed to the relevant event will be notified of that event along with a payload. That's basically what a subscription is. So it's a real-time event notification. It's very useful. And we use WebSockets in a GraphQL environment to do that. What is a WebSocket? A WebSocket is a fully duplex, nailed-up connection that's persistent. So it's not like a HTTP request that's stateless. You make a request and that's it. A WebSocket connection is established and it's there for the duration of the session. So it's used for things like real-time applications, chat type applications, that kind of stuff. Very powerful. So we're going to add WebSockets to our request pipeline and we're going to build a subscription. So let's get started with that. So let's move back over to our application. Excuse me. We'll stop the server running. We'll kill this stuff down. And as we've done previously for mutations and queries, we're just going to go to our GraphQL folder, right click, new file, and we're going to call it subscription.cs. Not subscription, subscription. Okay. So starting with a namespace as usual, namespace, command or GQL, and we're in GraphQL, and it's just a public class called subscription. Cool, and into that, tidy that up, into that we place basically a method signature that's going to be our subscription endpoint that our GraphQL client will call and subscribe to. So it's just a public, and we're going to return a platform object. And we'll need to bring in a namespace in a minute, and we're going to call it on platform added. So yes, just taking a step back, what we're going to do here is we're going to change our platform add mutation so that when a product is added using that mutation, we're then going to call the subscription event that will then notify anybody that's subscribed to it. So we're going to do it just on our platform mutation or platform object. So public platform on platform added is what it's called. And then we're going to introduce the concept of an event message. And what is that message? It's going to be of type platform. and we're just going to call it platform. And I'll just depluralize that, and that's going to return the platform. Okay, so let's bring in the relevant namespaces using Command or GQL models, and here as well using hot chocolate. Fantastic. Now, if you don't like writing it like this, if you want to be old school, you can write it like this. Return platform. Up to you how you want to do it, but you can do it either way. So I'll leave it like that. I actually kind of prefer this syntax for some reason. I don't know why. We're not quite done with this. We need to decorate it with a couple of attributes. The first one is topic. Topics really just relate to the type of subscriptions you can have. I'm not going to delve into that today. And then the other one is subscribe, which is probably a bit more obvious. It's just saying that we can use this method as a subscription, or we can subscribe to it probably more correctly. All right, cool. So we'll save that off. That's our subscription done. So the next thing I think we should do is move over to startup, and we've got two things that we want to do, or three, depending on the way you look at it. So in our configure services, actually, let's move down to in our configure method, we want to update our request pipeline to add WebSockets. So add app use WebSockets. And that's all you need to do. You don't really need to do any more than that. The hot chocolate framework does all the heavy lifting. So that's basically what we needed to do here. This is what we've done here. Cool. Fantastic. So back up to our services, we do need to add, as usual, add subscription type. Excuse me, my voice is giving out now. And we just say subscription. And then one other thing that you do need to add as well is add in-memory subscriptions. And this just allows us, whenever anybody subscribes, this just allows us to manage and track those subscribers in memory. If you're moving to a production type environment, you may well want to change that out and use a persistence layer to do that management. But for now, we're just using in-memory subscriptions, and that's good enough for us. Fantastic. And then the last place where we need to make a change is over in our mutation. And as I said, we're going to link into our add platform mutation. And we need to add a few more input parameters to our method. So I'm just going to take a new line for each of them just to make it look a bit neater. So we've got our existing ones, which is add platform input and our DbContext. So comma, and then we're going to add service. And what is the service? It's an iTopic event sender. And this is just what we use to actually, no surprises, send the event. And I'm just going to call that event sender. And then we should really hand over a cancellation token, which is something you can use to, well, as the name suggests, it allows you to cancel asynchronous method calls if they are hanging or something like that. So cancellation token, and we'll just call that cancellation token. And that should be as good. Now we need to bring in a couple of namespaces for iTopic event sender, which is using hot chocolate subscriptions. And then we need to bring in the threading namespace for this. Now we can actually make use of the cancellation token in one of our methods here in our save changes async. We can actually pop that in there if you want. So let's do that. It's probably good practice to do so. And then everything else pretty much remains the same. We construct our platform object ready to be added to the DbContext, which is then saved down. But before we return back, this is where we want to send off our event message and actually call the subscription here and notify anybody listening on the other end of the WebSocket. So await, and we use the event sender, send async, and this is where we hook into our subscription. So name of subscription, and we find the on platform added. Cool. And then what do we pass over? We pass over the platform object, and we also use the cancellation token if we need to use that at some point. And that's pretty much it, I think. So again, let's just recap. We added our subscription type, which will get added to our schema. Don't forget to decorate it. We needed to add our add WebSockets to configure. And then we needed to, of course, add subscription to the schema, and we were making use of in-memory subscriptions. So let's do a .NET build. And we'll then run it up. And in the next section, we will test this out. So let's just run it up for in preparation for that. So .NET run. Cool. So in the next section, we're going to test this. All right, yeah, so in this section, we're going to test that our subscription has worked. So the first thing I want to do is bring up Voyager again. We'll just refresh it to make sure that the subscription has appeared. So down here, we should see, yep, a subscription in our list of types that we have access to. So that all looks good. So now what we want to do is actually trigger our subscription. So what we're going to do is we're going to use Insomnia to add a platform as we have done before. And I've got a mutation ready to go here. Don't pay any attention to this. I was just when I was playing with it. And what we're going to use to subscribe to the subscription is we're going to use the Banana Cake Pop tool. So new Edge browser, and we'll come over here and it's just localhost and GraphQL. Now the reason we're doing that is, unfortunately, Insomnia doesn't allow you to subscribe to endpoints because, I'm presuming, because it doesn't set up a WebSocket connection, whereas Banana Cake Pop does allow you to do that. So over in our query window, rather than a query, we're going to type subscription. So you type query or mutation. This time we're typing subscription. And you can also just point your eyes to the fact that, yes, Banana Cake Pop is aware of our subscription. So on platform added, and then we just specify the payload that we want back. So ID and name, let's see. You can specify anything you want as per usual with GraphQL. So we'll click start. And what you'll see is no results going to get returned because nothing has happened yet. But what you will see is this little, I don't know what you call that, timer or something, just saying we're waiting. We've opened a WebSocket connection and we're waiting for events. So in theory, what should happen is when we add a new platform, and I'm going to add Red Hat Linux, we should see the payload down here, and we should also see an event here. So let's click send. And indeed we do. So we get the payload back, this time with an ID of 12, and likewise, we get our event notification over on our subscribed client. So again, think of the Banana Cake Pop client as a microservice that's just wanting to listen for certain things happening. GraphQL has a built-in mechanism for doing that. So it's really cool. It's really quite powerful. So with that, we are now done with subscriptions as well. Well, once again, we come to the end of yet another video and another long video, over 3.5 hours long. So congratulations for making it this far, and thank you for watching this far. Now, we covered a lot of material, but there is still a lot of stuff to cover in the world of GraphQL. The two main things that spring to my mind are the relay specification, which is a kind of idealized way of implementing GraphQL, which I recommend. And the other one is the data loader pattern, which speaks to something called the N+1 problem. Again, I won't explain what that is here, but it's definitely something that I would recommend we should look at some point, or you should look at in your own time. But, with that being said, those are the two things that spring to mind. There are lots of other topics, but they are topics very much for another time. So once again, thank you for watching this far. If you liked the video, give it a like. If you've not done so already, think about subscribing and you'll be notified when I make some new videos. All that remains is my supporter credits for those wonderful people who support me on Patreon. So thank you to you as well, of course, and your names are coming up next. So until the next time I make a video, stay safe, stay well, and I'll see you all next time.